Hey everybody! Hopefully everyone can hear me. Please let me know if you cannot hear me. This is a new thing that we're trying right now. We're going to be doing our first live stream tutorial. Some of you have been a little bit worried about whether or not this tutorial would go smoothly because with live streaming you can get easily distracted by questions. Again, please let me know if you can hear me or if you can't hear me. So the way that we're going to be able to do this, the way we're going to handle this tutorial to make sure that it goes as smoothly as possible for those of you who are potentially watching after the recording has already been streamed, we're going to be saving the questions primarily for the end. So any questions or comments that don't interfere with, I guess, the flow of the tutorial, or maybe even help with the flow of the tutorial, like if there's something wrong and you can even jump in and help or something like that, then anything else we're going to save for the end with kind of like a Q&A and also kind of like advanced insights. So this tutorial is going to be for anybody at all who has any experience programming or no experience programming. A lot of you, and this is by popular demand, a lot of you have indicated that you wanted there to be a Godot for beginners tutorial after seeing that the advanced tutorial that I offered a few years ago and I plan to update has so, it's a lot deeper, it's a lot harder to get into. And so with this tutorial, anybody should hopefully be able to jump in, whether you're a parent who wants to get their child involved in programming, or you're just a designer. Maybe you've worked with Construct, or Game Maker or something like that, and you want to be able to shift over to Godot, hearing that Godot has so much more potential than a lot of these other more basic game engines. All right, and the best way to be able to do this tutorial is to, one, you can follow along, but also I'm planning to do another live Q&A a week from now. So if you get behind, that's okay. If you feel like you're going to miss the Q&A, that's all right. We have one more week from now. We'll be able to do hopefully another live Q&A. All right, so let's go ahead and get started with this tutorial. I've been teaching this for a very long time, and the tutorial that I've chosen, the material that I've chosen, I specifically have chosen for it to be as accessible, as easy as possible, and also the best way for you to be able to use it as a diving board to whatever other kinds of games that you want to make. All right, so I'm hoping that this is not only the easiest tutorial that you'll encounter, but also it's one that isn't just going to get you in trouble with the more advanced techniques in the future. All right, so very cool. To get started with this, we have to set up our folders, right? So I have the Godot engine. If you don't have the Godot engine yet, then go ahead and go to godotengine.org and go ahead and download. This is the most recent engine for me, the 4.1.1 stable. Hopefully that remains relevant for a while. In the tutorials folder that I've created, here are the assets that I'm using for this 2D shoot 'em up game. All right, very cool. You might not like 2D shoot 'em ups. It's okay. I believe it's a perfect genre to be able to capture the non-specific fundamentals of a game engine. So you can get these assets in the description. If you go to the YouTube description, you should see both of the assets or the pack of assets that you can use for this particular tutorial. So for example, the QnA.nl, it's free to use. If you go there, QnA.nl, it's called the Space Shooter Redux. Go ahead and download that and extract it somewhere. And then also under opengameart.org, which is another fantastic resource, I went ahead and searched space background. And when I do that, you'll see that there's this one right here. It's Creative Commons, public domain. So it's free to use. Go ahead and download that as well. All right, so go ahead and grab those assets so that you're ready to go. Very cool. I have the assets all ready to go. If you start getting behind, that's okay. I'm going to have a little bit of a break between the end of this tutorial and when we do the live Q&A kind of little half-hour segment at the end. So don't, hesitate to pause if you need to be able to catch up or anything like that. All right, so cool. We have the assets. Now we're going to go ahead and start our project by simply opening up the Godot engine. And when you do that, very cool. It's like, you don't have any projects. Yeah, that's all right. We're just going to go ahead and do new project over here on the right. And as far as where the project is located, I'm actually going to just use my Windows File Explorer to create a new folder. And I'm just going to call this, I don't know, Totemic. 2D shmup, doesn't really matter. Just put it somewhere in some kind of folder that you're going to be able to get to. I'm going to go inside of it. And if you go up here into the address bar, you can simply copy. And when you copy, you can paste it here in the project path. You can also browse to it using Godot's kind of like editor browse window. But see, the thing is, Godot was actually not developed in Windows. To my knowledge, it was developed in Linux. And so a lot of times they don't really make use of the operating system specific file system. You can use the file system within your operating system. You don't need to use Godot's little like selector thing. In this case, I went ahead and copied the path directly and pasted it in here, and it's going to go ahead and put all of the starting project files right there inside of that folder. So I'm going to go ahead and don't worry about the renderer. It's not going to matter for what we're going to be doing forward plus compatibility. If you click forward plus and click create and edit, it might say something like, oh no, your computer's not amazing enough to do that, or something like that. You can just do compatibility and it doesn't make any difference. So go ahead and click create and edit. And I'm going to go ahead and resize my Godot window such that it fits the bounds of this like live chat as well as possible. So you can use this opportunity to kind of catch up with where I am. Very cool, 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 cool. Oh, perfect, I think. All right. Very good. I'm going to pull back up in YouTube so I can see what you guys are saying. All right, very cool. We're going to be creating a 2D project. So, I mean, it throws you into the 3D project by default for whatever reason. You can say you want it to be a 2D project by either, jumping over to the 2D view, or you can just simply create what we call the root node, the first node. It's not even really technically the root, but you'll see what we're going to explain that in more detail later. So I'm going to click 2D scene. And it's going to switch me to the 2D view automatically. And the first node that you see here in what we call the scene hierarchy, or the scene panel, is this node 2D node right here. All right, nodes are the lifeblood of Godot. All right, it's the most fundamental game element in any Godot project that you're creating. We're going to be talking about nodes a whole lot. But before we jump into it, let's go ahead and bring our graphics inside of our project. All right, so I'm going to jump back to that assets folder where I have downloaded these assets. And again, I'm using just this little Windows Explorer window in order to be able to do this. So you can either copy these assets and put them inside of your project folder within the file system of your operating system, or you can just simply click and drag them actually directly into the little file system tab here, little file system doc inside of Godot. So if I click and drag, for example, the space background by westbeam.png file, you'll see that it'll automatically import that file inside of my project. And the thing about that, and I'm actually going to click and drag the QnA Space Shooter assets, the whole darn folder, because you know what? I don't know which files I want from it, so I'm just going to put all of them in there. We can always delete ones that we don't need later, but I just want this to be as straightforward as possible. Notice how the file system panel now has our assets in it, but I want you to understand, I want to demystify this idea. We didn't put these assets like in our project directly necessarily. I mean, there's more kind of that's happening under the hood, but how you can think of the file system panel is really just a mirror of your operating system file system. So whether it be Windows or Mac or Linux. So for example, if I come back to tutorials and I look at 2D Shmup, you'll see that those very same files, this little PNG file and the QnA Space Shooter assets folder, they're now located inside of my little file system page and also in the file system doc here. If I delete it here, it'll be deleted from the project as well. So you can just think of those as basically kind of mirror images of each other. These little import files are created automatically by the engine in order to be able to make them usable as graphics inside of our project. Don't worry about those, just let them be. All right, very cool. So now that we have our graphics in place, what I want to do is I want to first test my project. Why not? You know, everyone wants to test the project. So to test the project, you can click this little play button at the top or hit F5 on your keyboard, at least on Windows. I'm not sure about Mac. But anyways, if you click play, it's going to say like, hold on, no main scene has been defined. Do you want to select one? It's like, yeah. So there has to be an entry point to our project. you could have hundreds of scenes, so to speak, inside of your Godot project, but the engine needs to know, well, what's the first one? Like, what's the starting point of your project? And so I'm going to click select current because I want the current unsaved scene that's currently, I haven't saved it yet, scene to be my main scene. And main is the conventional term we use to describe this starting scene. So I'm just going to type main here, main.tscn. Very cool. When I hit save, you'll see that the main.tscn file is now inside of this file system doc over here in your bottom left corner by default. I'm just using the editor defaults, by the way. I'm sure that you can change these docs around. I'm not going to spend too much time with that. You can kind of mess around with that on your own time. And here's the game being tested right here. Now, this little weird halo that you see is just kind of this little mouse cursor thing to make it easier for you to see the tutorial. It has nothing to do with the game engine. This like little blue circle around my mouse. All right, I'm going to go ahead and close this. And the shmup window, I want this to be more for like a mobile device, right? The typical type of the old-fashioned arcade 2D, shoot 'em ups are kind of more vertically oriented. So this right now is kind of more horizontal. I'm going to change this so that it's vertical. I'm going to change what we call the window size of our project, okay, for when you're playing the game. And you can do that by simply clicking project and then project settings. When you do project settings, this allows you to change the project, the settings that are specific to the project, not to Godot as a whole, just for this particular project. So if you have other projects, you can have different settings for the different projects that you want. So I'm going to go ahead and click under here, under display and window. Here's your what we call the viewport width and the viewport height. The viewport is the visible area of the game window. Now, if you're making a game where there's scrolling, like in a Zelda game where you're kind of like moving, or like Mario game, just whenever the screen is scrolling, the viewport is still a fixed size. Your world may be really, really big, maybe tens of thousands of pixels in each dimension. But for the window, it's gonna remain fixed, and you can always adjust that. I don't want to get into too many of these things because what I want to focus on is the stuff that are the bigger gotchas. Like these types of things you can find in just about any tutorial. So I'm going to kind of breeze through these things pretty quickly. The resolution that I'm going to choose a viewport resolution of 540 pixels wide by 960 pixels tall. This is just going to make it so that my little like 1080p screen, it'll fit easily so that you can see what I'm doing, and it's still that 16 by 9. Very cool. We're just going to go ahead and go with this. Now, there are advanced settings that you can kind of look at. I wouldn't worry about it, but if you're having trouble with your screen because you have a very high density kinds of resolution, you can always adjust this. You can click or unclick allow high DPI if you're following me. You just fall behind just so quickly because you can barely see anything. Okay, I'm going to go ahead and click close. Okay, sorry. It looks like some of you are at a different time zone. That's all right. You can come back in, and hopefully in a week we're going to do a live Q&A. We're going to do the live Q&A and also the advanced insights at the end of this tutorial, and also hopefully in a week so that you can kind of plan ahead. This was kind of short notice. Now, as I move my viewport around, you'll see that this like rectangular box here in the middle of my main editing window is now this kind of vertical rectangle. So if I click play, you'll see that, very cool. The settings that I just changed reflect what we see here in the little play window when I hit play. You see this word debug. It's basically saying that we're able to test our game here inside of this window. Very cool. Now that we have our window ready to go and we're able to test and play, why don't we just go ahead and bring our first graphic inside? I'm going to start with the background. So this space background by Westbeam, I'm just going to simply click and drag it directly inside of the editor because you know what? That's what you might think to do intuitively as a beginner. So let's just start with that. If I use the little scroll wheel on my mouse, I can zoom in and out, and I can adjust the size of this graphic by clicking on it and then using the little control handles in the corners and etc. And it doesn't really matter even if I'm stretching this image around because it's space, right? Like space bends. I watched the movies. It bends. All right, anyways, it doesn't really matter. And notice how when I hit play, you can see very quickly that, yay, it looks like an actual space game without anything in it. which is kind of more accurate to space, right? Not a lot in there. All right, very neat. I'm going to come back up and I'm going to look at my node panel, my node hierarchy here. You'll see that there's a new node. And that node is, it looks like it kind of descends here from this node 2D. And that's a good way to think of it, okay? Because the node hierarchy works like a tree. Just like a tree, you have a trunk, which is basically the root. This node 2D represents the root of our main scene. All right, very cool. And then we have a child of that main node, which is this graphic. And you'll see that it has a little fancy face on it. But if I hover over it, you'll see that already the type of the node is different. Notice how it says type sprite 2D. When I hover over this one up here at the top, it says type node 2D. Those are two different types of nodes. It automatically assumed that by clicking and dragging this graphic into the editor that I would want a sprite node, because sprite nodes are the ones that allow you to render the graphic. All right, cool. I don't like this name, so I'm going to actually double click on it and I'm going to change it to space background. Okay, very cool, so that it's a little bit easier to see. And I'm going to double click where it says node 2D while I'm at it, and I'm going to change it to main. And by convention, we capitalize our node names. It's not mission critical. It's not going to break your project if it's not capitalized, but I'm just going to stick with general convention. Just looking at the chat. Dude, I missed you. Oh, thank you. I love the sport. All right. Now, here's one thing that is easy to forget to do. This space background is where we want it, but it can very easily, and by the way, I'm using the middle click and drag in order to be able to pan around my editing window so I can see the various elements inside of the window. Very cool. And again, scrolling up and down to zoom in and out. All right. If I were to try to click and drag various other objects around on the screen, I might accidentally click and drag on the background and whoops, I could move my background, which could get very annoying. And since I don't really have anything else to do with this background, at least for a while, I'm going to lock this node. So with the space background node selected, I'm going to simply click on this little lock icon in this little toolbar at the top. And now I can no longer accidentally click and drag and move the space background away from its original position. Very cool. So hopefully you're following along, because I'm just going to roll on ahead. I was going to say steamroll on ahead, which is kind of a weird thing to do. All right, let's go ahead and create our player, because what's a game without a way, a player? I guess games get pretty interesting. Some games are just like sit and look at the screen. It's like, how is this a game? Anyways, to make the player, I'm going to do it a different way. Instead of clicking and dragging out inside of the editing window, I'm actually going to select the main node, and I'm going to click plus in order to add a blank child node of the main node. Now, you could maybe accidentally do that. You could have space background still selected and then click plus. That's not really what you want to do, especially since the space background is locked. You won't be able to really move any of the children of the space background. But otherwise, it's not really the end of the world, and you'll learn as we go that exactly where your nodes are placed will have an effect, but they don't instantly break your project, okay? And so we're going to think about that as we move forward. So with the main node selected, I'm going to click on this little plus icon, add child node, and here's where we ask, and this is a lot of times where beginners just immediately are like, what the heck am I supposed to do? Because a lot of the more basic game engines, you just can like click, and it'll just be kind of a little wizard where it's like, click, create player node or something like that. Well, with Godot, it's a little bit more freeform, which is awesome. It gives you a lot more power. We're going to start with just a node 2D, because the node 2D is the most basic node that you can move around in 2D space. There are so many different kinds of nodes. I'm not going to explore all of them right now, but starting with node 2D is generally a relatively safe place to start, and we can always adjust as we go. So I'm going to go ahead and click create, and node 2D is currently the default name. I'm going to double click on it in order to rename it, and I'm just going to simply rename it to player. Now you can't see anything, and you can't change the graphic. Notice how in space background we have over here in what we call the inspector bar, or the inspector panel or dock. I don't know what Godot officially calls this. Darn it. Anyways, but it's the inspector. And you'll see that a property of sprite 2D nodes is that they have a texture, right? And that's the graphic. Now, all sprite 2D nodes are also node 2D nodes, which means they possess the features that Node 2D nodes have, which is specifically a position, a scale, and so on. Notice how I can rotate them. They all are able to do that if they are Node 2Ds. Sprite 2D is also Node 2D. All right, when I actually click in here, you'll see that these are all different kinds of Node 2D nodes. Kind of like there's animals, and then there are mammals, and then there are cats, and then there are, you know, cats that you find in memes, house cats. They're all animals, and they're all mammals, and they're all cats, etc. And it's the same idea. We use this kind of inheritance system where it inherits the different properties of those more basic types of nodes. So Node 2D is kind of the most basic kind of concrete node you can move around in 2D space. Sprite 2D, as you can see here, inherits from it, and therefore gets all the magical cool powers that Node 2Ds do as well. But this player node is a Node 2D, and so it doesn't have the little sprite texture thing. So at this point, you might be like, why didn't we just make player a Sprite 2D node? Well, the thing is, let's consider the composition here. The player might not just be a single, you know, static graphic, right? It might have a, you know, you might have a ship, it might have a thruster, you might have all sorts of other fancy things attached to it, you know, different effects, a shield graphic or whatever it might be, and they all belong to the player. So let's just give it this basic container, the Node 2D, and instead of making the player a sprite, we're going to make the player have a sprite child, and that's what we're going to do next. So with the player selected, I'm going to click on the plus icon again, and you can have, any node can have as many children nodes as you like. So I'm going to go ahead and click plus, and I'm going to create a Sprite 2D child of the player that's going to represent the ship graphic for our player. So I'm going to make sure Sprite 2D is selected, not Sprite 3D, don't do that. And click create, and I'm going to change this node's name to, I don't know, let's call it ship graphic. Ship graphic. And currently there's no texture assigned to it. So we're going to assign a texture by clicking and dragging one of these graphic files from our file system, not inside of the editing window like we did before, which would just create a new Sprite 2D node, but rather directly onto the texture property inside of the inspector. So with the QnA Space Shooter Assets folder expanded, let's go ahead and look for a graphic to use. All right, very cool. Let's go under PNG, which are kind of the static images, and we scroll down here and we see that there are player ships, but I am not gonna just follow the rules. I'm gonna go with the enemies. Those are the ships that I'm gonna use here. So I don't know, let's go through, I don't know. Let's use the one that was in the thumbnail, I think. It's like enemy red 3. That's a cool ship. Let's go ahead and click and drag enemy red 3.png. And I'm not going to let go here. I'm not going to let go here. I'm going to keep going. And I'm going to let go of this graphic. Notice how it goes from this little no smoking sign to like, yes, we can do it. Once you're over this little empty little field in the texture property, and boom, bam, bam, we can see that it appears inside of our editor. And there it is. We have a ship graphic. It has this wonderful image. And you might be like, why are we using this enemy ship? You know, maybe the player hijacked the enemy ship. And you know, also maybe we should always stop and think for a second, are we the baddies? Like maybe we're the bad guys. And we, you know, it's just we've been led to think we're good. All right, so I'm gonna actually zoom in on this a little bit just so I can see what I'm doing a little bit more. This ship is a little big. So I'm actually going to smallify it a little bit. And when you look over here, there's no obvious choice. Unfortunately, if you're a beginner, you don't necessarily know where to go. So you can just kind of click and like open some of these drawers to see the properties, and so you can get a better idea. And as you just kind of open drawers, which is fine, you know, kind of like when you just put like your old HDMI cables in some random drawer and you forgot which one it was, you just kind of like open all the drawers to find what you're trying to find. All right, well, here it is, scale. That looks good. So under transform, this drawer, as we're calling it, basically a category of properties, you'll see there's position, rotation, and scale. And these are your 3 primary types of ways to manipulate how the object looks inside of the screen that you'll find in every game engine probably. So I'm going to adjust the scale. I'm going to change the size from 1, which stands for 100%, the size, the pixel size of the texture as it was loaded. So this was basically the size that Kenny had intended it, but I'm going to change its size so that it fits for my game better. I don't know, 70%, so 0.7, so that it's 70% the original size. You can go ahead and adjust that. By default, it constrains the proportions so that it remains as wide and tall proportionally as it was originally. It's still a little big. You can kind of adjust it if you like. I'm just going to go with that for the sake of time. And it's facing down, but I want this to be more like a traditional, you know, arcade shooter like Galaxy and Namco from the, what is it, the 80s. So to make it point up, I'm going to click where it says flip V, which stands for vertically flip the graphic, and I'm going to click on. And so you might wonder, it's like, wait, why are we doing this to the graphic when we should just maybe do it to the entire player? And the answer to that question is it's the graphic that's the problem, right? Other graphics that we have, shield graphics, thruster graphics, other types of things like that might be scaled differently, right? So scale each graphic as necessary. If you scale the player, then notice what happens. When I scale the player down to like 0.5, it also scales all of its children, all right? I'm going to keep the player at 1:1 so that it preserves the default sizes of everything, and you can just adjust those things directly on the child nodes where it is relevant. Now get ready, okay? Pause for a second and watch what we're about to do, because this is fundamental to the problems a lot of users, a lot of beginners have with Godot, all right? Put your thinking caps on. I hope you ate your thinking food like apples and granola or whatever you eat. I want to move this sprite, this player, down here to the bottom of my viewport. Here's the problem. This is what beginners will do by default. They'll click and drag. See, notice I click and drag, but notice what you've done inadvertently. If you were to click and drag this all the way down here to the bottom, you might think, oh, well, you know, there's no problem. I can hit play and you can see, hey, look, the player's down here at the bottom. What's the problem? I don't see any problem with that. The problem with this is, where is the player 2D node? Notice how when I click on it, it's still up here in the top left corner. The top left corner is by default the origin point, that 0, 0 point. Notice how the position 0, 0, that is the world 0 point on the viewport. And that applies to any type of like web graphics or image graphics or photo graphics that you're going to be doing. And it's the same thing with game graphics. The top left corner is by convention the origin point of your viewport. And so my player is still up here. So if I click and drag, you can see, oh, wait a minute. When I move the player 2D node, which is, again, invisible since it's a node 2D, it is not a sprite. If I click and drag, you'll see that, uh-oh, it moves all of its children because children follow their parents by default. I don't know if that's true in the real world, but in the Godot world, that's what happens. Nodes follow their children. So if I click and drag the parent node, the player node, the child will follow the parent, but notice how it is now offset from that position. You might be like, what's the big problem? Well, it might not necessarily be a humongous problem, but the thing is, I'm not just trying to move a graphic, right? I want to be able to move all of the graphics simultaneously. We're going to be getting into collisions where there's the extent to which enemies are able to crash into the player. That itself is separate from the sprite, and we want that to also move alongside the player. And so we want everything to be as lined up as possible right here inside of the center point of the parent, all right? Now, so that we understand fully, this position that we see here, you see where it says 147, 345, the up and or left and right on the x-axis, left is closer to 0, and then negative actually, once you're outside of the viewport, and then right is positive, right? Left is negative, right is positive, and then down is positive. As you can see in the y-axis, it's now 752. The closer you get to that 940 tall viewport, 9 is positive, up is negative. So just keep that in mind. So if I were to put my player over here, you'll see that 228 pixels from the left, 710 pixels from the top, but look at the player. Look at the sprite, see, 228, 710 with the node 2D, but the ship graphic, it says that if I look at the transform, you'll see it says 114 and 98. That doesn't seem right at all. Well, it's 114, 98 from what? If I click and drag my player node 2D again, the parent, you'll see that the parent changes. See, it's like depending on the viewport, but if I click on the graphic again, it's still 114, 98. Because how Godot works is that the transform is with respect to its parent. I already showed you that you can scale the parent and it also scales the children. In a similar kind of way, the children refer to their parent. So the position property is relative to the parent's position, not to the viewport's position, not to the world position, okay? So because of that, I want the child to remain at 0, 0, okay? Fixed right there in the center of the parent node, this player, and we're gonna let the parent node traverse the viewport. Now, here's the problem. If I click and drag, you'll see that it's always just gonna select that, you know, childmost node in the stack of nodes in the viewport. So I don't want to do that. I want to move the whole darn player. So to make sure that I don't accidentally click and drag this child node over and over, I'm going to select the parent and I'm going to click on this little icon at the top, group selected nodes, or Control G. This basically says you're like tethering, you're making it impossible for the child to get away. You're like locking the kid to the parents, you know. So now you can no longer in the viewport separate the child from its parent. All right, very cool. I'm going to go ahead and click and drag this down. Notice how I remain selected to the player 2D node, the node 2D node. I'm going to move it down here on the bottom. You might be thinking like, gosh, why do we have to think about all that right now? Trust me, this is one of those things where I'd like to normally just let you dive in and make mistakes, but this is one of those things that you have to know right off the bat. All right, gonna go ahead and hit play, and ta-da! Our player just sits there, doesn't do anything. Okay, very cool. Hopefully this is making sense so far. I see that some person wrote handcuffs. Yeah, it's like handcuffs. Is that what that is? Is that like, it looks kind of like handcuffs. All right, continuing on. Right now, we want the game to be interactive because typically, I think almost anybody's definition of a game requires some level of interactivity. So we want the game to be interactive, but we have to decide, well, how do we interact? How do we want to make it interactive? For this particular demonstration, I'm going to make it so that the player follows the mouse, okay, but stays on the bottom of the screen. All right, so it allows us to move as quickly as our mouse is able to move, but it stays on the bottom of the screen. So now we are on the same page of what we're trying to execute. How are we going to do that? Well, to do that, we have to create what is called a script. Okay, the script is the brain of the node. It allows you to control the node. Otherwise, the node just sits there doing nothing. You need some kind of script to have the node do something. So where are we going to create a script? You could create a script in any number of places. Now, those of you who are coming from something like Construct, or gdevelop, or Scratch, or something like that, you're probably more used to this idea of like the top-down approach where like there's one main script that controls everything from above. That's not how we do things with Godot, or for more modular types of game engines such as Unity and Unreal. You have to break yourself from that. In Godot, think of it that every node is a big kid. It can handle itself. We don't need some parent node like the main node to tell the player what to do. We're just going to have the player do what the player is going to do by creating the script directly on top of the player node. Now you can apply a script to any node you like, but we're going to do so right here on the player by having the player node selected. And I'm going to click on this little add script or attach new or existing script to the selected node. Looks like a little script with a green plus icon. Hopefully you can see it on my screen. And with the attach node script window visible, I'm just going to go with the default, okay, just like an empty template. Now, by default, it has player.gd capitalized. We're going to save it to the end of this tutorial to talk more about those naming conventions. For the sake of your sanity, I'm just going to go with what Godot has chosen to be the default, even if that isn't consistent entirely with their own recommendations. All right, very cool. Player.gd, we're just going to go with what it says, and it says res. That res refers to the root folder, the file system of our project, which will put it right here in the root of the file system page, the file system doc over here. All right, go ahead and click create. And when I do that, I want you to understand that by doing that, you see it's now a file inside of my project folder. Okay, very cool. I'm just going to delete everything. I don't like having to look at stuff. It's so much nicer when it's just clean and we can start from scratch. All right, except for this. We have to keep this extends node 2D thing. Otherwise, you're not going to be able to have the ability and features to manipulate your node inside of the viewport. So keep this extends node 2D. It'll make more sense as we go. So we have to ask ourselves, all right, so what are we trying to do? We want to make it so that the player node moves to the mouse position. And you have to ask the question, well, when do you want that to happen? I want it to happen all the time, right? I want to happen every moment of the game. I want the player to move to the mouse location. So whenever you have that as the situation, as the condition for when this action you want to occur, you're going to put it inside of what's called the process function. Okay, that's underscore process. That is the name of this function. All right. In other game engines, it might be called like every tick for construct. It might be called just tick for like Unreal. It might be called update, depending on the like, you know, Unity or something else like that. In Godot, it's called process. And so in order for Godot to kind of write it for me, notice how it didn't like help me out in typing this, because it didn't know I was trying to create the process function. So if I want to create the process function, I'm going to use what's called the func keyword, just like you had seen before I deleted it, F-U-N-C, func. Now when I click the underscore key on my keyboard, you should see that, okay, it has suggestions. It's like, here are the built-in functions that exist for Node 2Ds. And if I start typing in process, you'll see that we're just going to go ahead and let it autocomplete by either selecting it with the arrow keys and hitting enter, or just double clicking on it inside of the list. And then boom, bam, bam, we have our process function. Okay, very cool. Already it's yelling at me, right? If I click play, it's going to be like, what do you do? Oh, it didn't crash, which is actually kind of surprising. But it's saying like, hold on, your function is empty. Like, what are you doing? You got to write something. All right, so we want to test this. This process function, that is to say that anything that is indented underneath this, what we call the function definition, is going to be executed every single moment of the game. So let's test this out by using a print statement. Print is the name of a function that will display whatever you type between the parentheses inside of this little output log at the bottom here of your little Godot editor. This allows you to what we call debug. And this is awesome because a lot of times your code isn't doing what you're expecting it to do. And this is a really good way to see where you're at. Is this function even being called? So just do a quick print function. And then in the print function, I'm going to type a string, which is a value in quotes. And I'm just going to say something like, this happens every moment of the game. And so now when I save my document, Control S, and hit the play button, you should see that inside of the little output log, you can see 270, 300, 400, you know. This is just happening constantly. This happens every moment of the game. This happens every moment of the game. Wow, it's printing that all the time because this line is being executed every moment of the game. Very cool. Hopefully that makes sense. Now, I neglected to mention, but we're in the script view. When we click create script, it automatically jumped us to the script view. That doesn't mean that we have, you know, entirely abandoned the ability to modify our viewport. You can go back to it just by clicking a little 2D or script or 2D or script or 2D or script. And you can also, in the 2D window, you can jump to a specific script by clicking on the little script icon inside of the view, inside of the scene panel. And all of your scripts that you're working with also appear here on the left. It's really convenient. It's really awesome that Godot just has this out of the box. You don't have to download a different editor. All right, I don't want this to print every tick anymore. And when I say tick, whenever I say tick, I am referring to every frame of the game, every execution here of this process function. I don't want it to print anymore, but I want you to still be able to see what I've written. So I'm going to create what's called a comment. To create a comment, I'm just going to create this little octothorpe icon, Shift-3 on the keyboard, at least on an American English keyboard, in order to be able to what we call comment out the code. When I comment out the code, In fact, I'm not going to create a space. I'm just going to make it right here so that we know that this is code. It's not like a comment that I'm reminding myself of what I was doing. But now when I hit run, you'll see that it no longer says anything here in the output log. I'm going to go ahead and click stop. Awesome. Now that we have verified that the process function works, let's go ahead and figure out how we're going to make it so that the player node is effectively attached to the mouse position. So how do we do that? First, we have to understand how to change the position of our node. Now, the best way to know the kinds of things you can modify about a node is to look at the inspector panel. That's your hint. If you click on the player node here in the scene window, look down here, all this stuff like visible, on, modulate, all this kind of fun stuff, position, rotation, scale. These are what we call properties. If I hover over it, you'll see that the property associated with this node 2D here called position is actually lowercase. See, it says position, right? Same thing with rotation. If you can change it in the inspector, you can change it in the code. All right, you get it? Unfuzzing someone fork. All right, very cool. Let's go ahead and figure out how to change that position then. So position is the property. Notice how as soon as I start typing POSI, you'll see that it's auto-completing. And the way that it knows that the position property is available is because of this line up here at the top that says extends node 2D. Okay, it's a property of node 2D. And so when I type this, I can hit tab to autocomplete. Very cool. Position, well, what do I want to do to the position, right? I can set the position using this position property. All right, very cool. But what do I want to set it to? I want to set it to the mouse location. All right. The mouse location I can get by, if I could just start typing in mouse or something like that, if we get all these things that have to do with a mouse. And if I scroll through here, this is another way that you can get to see some of the features that are available to you inside of the code editor. And notice how there's nothing to do with mouse over here in the inspector. This is not the limit to what you can do, just what's in the inspector. We can also get the mouse position at any time because it's also a feature of node 2D. So if I click mouse and I scroll through here, you can see that there's get local mouse position and get global mouse position. We want to get the global mouse position because the local mouse position is useful in some ways, but it's talking about where's the mouse with respect to this node. I don't want that. I want the mouse where it is in the world so I can move my node to where the mouse is in the world. Okay, so I'm going to do get global mouse position. You know, when in doubt, just do both. Well, you might as well, right? It's like there's no harm. Just try things out. And if you're ever like, well, how, you know, I want to learn more about this. If you hold control, notice how these different properties in this function here they highlight with this underscore. If I control and then I click, it'll open up here on the left a new little window. It takes me out of my player.gd and it says canvas item and it jumps right to what we call the documentation that describes that particular feature. So this function, get global mouse position, it tells us, returns the mouse position on the canvas layer, blah, blah, blah. That doesn't mean a lot to you necessarily right now, but just know that at any time you can learn more about the thing you're trying to do by just control clicking on it if it's built into Godot. I can right click and choose close. And you'll see, wait, what is canvas item? I thought it was in the node 2D. Well, again, and I'm just gonna be very brief about this, if you look at node 2D actually technically inherits from canvas item. But canvas item is gray because a canvas item is not something that can go inside of the viewport directly. It's not concrete, it's abstract. So node 2D is still that most basic of 2D nodes, but it has features that it gets from canvas item. You don't have to worry about all that right now. Okay, don't worry about it. Just know that you can get the mouse position by doing get global mouse position. Oh, wow, thank you for the tip. All right, very neat. So what do I want to do? Get global mouse position. And it says it returns it. When it says it returns it, it means you can set its value. So when you call this function like this, and you need those parentheses, and it automatically filled them for you, so don't get rid of them. When you call this function, you can set this value to a variable. So I'm going to click var, V-A-R, short for variable, and I'm just going to call it mouse underscore POS for position. And I could have called this anything I want. I could have called it mousy poo. It doesn't matter because this is just a name that I've given the result of calling this get the global mouse position function. I didn't need to do this. I could have gone straight to get global mouse position, okay? But I'm going to do position equals mouse POS because I want to set the player's position to the mouse position. Now when I hit play, you'll see that, ta-da, cool. Again, that halo is not like a shield for the player ship. It's just my stupid little like highlighter thing for my mouse. All right, see, notice how it follows the mouse position. Awesome. I also want to point out again that I could have just gone straight here and just did, you know, position equals get global mouse position directly. And you'll see, ta-da, it does the same thing. But it's nice to be able to create a variable like this, especially because we don't want to set it to the Y position of the mouse. We only want to set it to the X position of the mouse. So if I want to set the position to the mouse's X position, the X position of the player to the X position of the mouse, I want to get not just the whole position, which it has an X and Y component, or what we call property. We can access those specific properties of this compound property. When I say compound, as in it's a property that contains two different properties. In this case, it's actually a vector. It contains two different properties, both X and Y. So when I hit dot, there's some cool stuff we can do with it, including like what is the angle, the absolute value, all that kind of stuff. But I'm going to just do X, position.x, and then mouse POS.x, so that when I hit play, we're setting the X property of the position to the mouse X property. Now when we do this, ta-da! Awesome, it works no problem. If that didn't work for you, make sure that you are doing that .x on both sides. You can't just do it on one side because then it'll be like, you can't set one number to like something that has multiple numbers in it. Like that's confusing. Very cool. So hopefully that worked for you. All right, very, very good. Again, I like using variables like this because it's just kind of gets a little bit gross when you have like a huge line with a little .x at the end like that. It's kind of harder to follow and also harder for you to work with this. The mouse position is something you might continue to use further on in this function, so having it just ready to go without having to call this function makes it a little bit easier to read. Okay, hopefully that worked for everybody. Let's go ahead and continue. What I want to do next is I want to make it so that we can fire a projectile. Because what's a shoot 'em up if you can't shoot them up, right? So we got to shoot. Well, we're going to start with the shoot, and then we'll get to the M. Very cool. So I want to create a projectile. And here's where we have to stop and ask ourselves a question. Well, I'm going to first come to the 2D viewport. When I create a new node, because that's what I know I'm going to have to do, I want to create a projectile. So you might be thinking, where do I want to put it inside of my scene tree, this tree of nodes in my scene window? Where do I want to put it? Well, a lot of you might think like, well, it's the player's bullets, so it should go in the player. Let's go ahead and do that just so you can see what happens. You don't have to follow me because I'm going to fix it, and you can fix it too. I'm going to click add this new node. And similarly to the player, I want this projectile, this laser, to be a node 2D. I'm going to start with node 2D. I don't want it to be a sprite because, remember, it's more than just a graphic. It's going to have to collide with something, so it needs to have more than just an appearance to it. So I'm just going to start with node 2D. I have this node 2D selected, and then click create, and very cool, I'm going to call it laser, spelled with an S. And you might be like, oh, that's cool. But before we do anything with the laser graphic, I just want to point out, okay, well, where is this laser, right? Is it here? Where is it? If I kind of click on stuff, you'll see that, oh, the laser apparently is like maybe here. Well, again, don't follow me. I just want to show you why this is a problem, okay? I'm going to undo this whole like child lock so that I can like move the laser around. See, this is the laser. Cool, it's a laser. Notice the problem that we have. So if I lock this child lock thing again, if I click and drag the player, you'll see that this is the laser. I haven't added the graphic yet, but this is where the laser is going to be. If I click and move the player, you'll see that the laser moves with respect to the player. Unless that's like how you want it to work, that's generally not how you want it to work. You want that projectile to be free. You want to set it free, right? You don't want the player to like continue to move it along the x-axis after you've already shot the projectile. So you don't want that. Even though you think the laser belongs to the player, you can make it belong to the player in different ways than to like make it a child node. So, okay, I don't like where it is. I'm going to click and drag this. I can reparent is what we call it. Reparent. It's like adoption or something. I want to reparent the laser to be a child of the main node by clicking and dragging and simply hovering over the node in the scene tree that I want it to now become the parent. Cool, now the laser is what we call sibling of the player. See? They are no longer bound to each other, so that when I move the player, boop, 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 it doesn't change the position of the laser. That's where I want it to be. Very, very cool. Okay, I hope folks can answer questions to each other inside of the live chat. Again, for the sake of this being as seamless as possible, for those of you who are watching the pre-recorded version, I'm just kind of barreling through, and then I'll look back through the questions and answer them as we see fit at the end. All right, very cool. Well, we can't see the laser, right? So let's go ahead and add a graphic to the laser. I'm going to reduce the size of the little enemies drawer here inside of the file system panel, and I'm going to look for lasers, and I'm going to expand this, and it's our ship is red, so let's go for a red laser. I don't know, laser red 4.png. That looks kind of cool. So I'm going to go ahead, and I don't want to click and drag this out here. Okay, if I clicked and dragged it out here, you'll see that it's not next to its parent, all that kind of stuff. It didn't even make it as a child of the laser. It's just, we're already messing up right off the bat. So I'm going to go ahead and do it the way that I recommend doing it, which is to just add a child node to the laser. You can click on laser and click plus like we've always been doing, or you can just right-click laser and choose add child node. Sprite 2D is what we want. Cool. By default, it's called Sprite 2D. I can just call this laser graphic or something like that. Doesn't matter what it's called. And then for laser red 4, I'm going to click and drag it directly into the texture property. This way, I know that it is 0, 0. Whoops, transform 0, 0. It's right there. And I don't want to accidentally move it from its parent. So with the laser parent node 2D node selected, I'm going to click on this little lock child handcuffs. Is that what we call it? That's morbid. I don't know if we should be using handcuffs with children. Anyways, but it can, that laser graphic can no longer accidentally become offset from its parent's position, at least accidentally. We can always manually type in numbers over here inside of the inspector. All right, very cool. I'm gonna put it over here, and if I save and I hit run, you can see that, hey, look, it's a laser, and it's just sitting there. It's like we're traveling so fast that our like laser is just like looks stationary. Is that right? Are we doing some kind of bullet time? No, it's because we haven't done anything with it. Okay, well, what do we want it to do? Well, we want the laser to go up. That's how these lasers work in classic arcade shoot 'em ups. So how do I want this laser to go up? I don't want just the laser graphic to go up. I want the whole darn laser to go up, including all the animations and all the like collision boxes and stuff that have to do with the laser. So with the laser selected, I'm going to do what I did with the player node, which is that the laser, if we want the laser to do something, as this independent node, we're going to give it its own script. You might be like, whoa, hold on, another script already? Again, those of you who are coming from a different type of game engine might be used to just creating everything in like one big like document or something like that, which is more intuitive, I concede, for a beginner. But when we're talking about Godot, and especially a lot of these other kinds of modular kinds of game engines, you're going to create many scripts. And don't be afraid to create however many scripts you want. You can make a script for like every node if you want. That's kind of weird. I don't recommend it. But it's not going to bog down the engine or anything. So I'm going to go ahead and with the laser selected, I'm going to go ahead and click create a new script. And again, I'm just going to go with the default that Godot decides. I'm surprised that they're going with Pascal case with a capital letter. Again, I'll talk more about that hopefully at the end. I'm going to go ahead and click create. And again, now we have it switches to the script view, and it created a new script, and it says laser.gd. I'm going to delete everything again because it's like, I don't know, I'm like a vampire who just saw light. It's like, it's delete. I don't like all your the stuff you gave me. Because we're going to do it ourselves. So what are we going to do ourselves? We want the laser to move on its own. How do we make it move on its own? Well, we first have to decide what we want to do, right? Think for a second, okay? We call this pseudocoding, right? Just think, what is the mechanic? Like, what are we trying to do? Well, we want to make it so that the laser goes up. And then you ask the question, when? when should the laser go up? And the laser goes up similarly to the player whenever it exists, right? We want it to move every moment of the game. So other game engines, you might like be setting like a velocity or something. That's not what we do, not for this. So we're going, I guess if you're doing like physics stuff, you can set velocities and stuff. We're not using physics stuff here. We're just going to move it in the most basic way possible. And that is just, again, using the process function. So func_process, just like we did before. And similarly to the player, we're going to change the position property, right? I don't want to like tell you the answer all the time right off the bat, but you know what? Hopefully you understood from before that in order to make something move, you have to change something, change its property. And in this case, to make its position change, you have to set new values to the position property, right? There's that position that we were talking about. Now, if you look very, very darn carefully, and again, I'm using the defaults for the editor. I recommend changing this inside of your editor settings, but I'm not going to do that right now. If you look extremely carefully, it goes from gray to like light blue. See? And if I add another N, it goes back to gray. Okay, that light blue indicates that this is a property that the code editor recognizes as belonging to this particular node. So position, very cool. So well, what do we want to do? We want it to just go straight up. So what property of, hey, thank you for the tip. What property of the position property, again, that dot means access a property of that object, all right? So when I say the position property, and when I say the y property, when I say dot y, I'm referring to the y property which belongs to the position. So you might be thinking like, wait, but if it's the position property, then why aren't you using a dot, right? Because the y property, to access it, you need to use the dot. So the thing about it is in Godot, whenever you just start typing a property, it is shorthand for just typing in self.position or self.property, okay? This is important to recognize because this will clarify problems that you might have later on. So when I say position.y or position.x, it's the same thing as typing self dot and then accessing the properties of self. Self is a special variable that we use inside of our editor, which refers to the node that the script belongs to. Okay? The script belongs to the laser node, which is a node 2D. So when I say self, I'm referring to the laser. Self.position. If you want to, you can always type self. I like to do that because it becomes extremely clear that I'm not dealing with what we call a local variable. See, if I say self.mousePOS, it doesn't know what the heck this is. It's like, what the heck is that? Because this is not a property of the node 2D. It's just a variable that I've created out of thin air inside of this function. You understand the difference? All right, very cool. So coming back to the laser, I'm going to go ahead. Hey, thank you for the tip. I'm going to go ahead and erase self for now. I'll probably use it again later, but I don't want to burden you with too many extra things. Position.y, well, what do I want to do with the position.y? I want to set it to some value, right? What do I want it to be? I want it to be like 5 every single tick. If I go ahead and click play, you'll see that there it is at 5 every tick. Well, I don't want it to be at 5. I just want to change its position by a certain amount. So to change its position by a certain amount, we can use plus equals, or minus equals. Minus equals means change this property by the right-hand side, by the value on the right-hand side. I'm actually going to embiggen this text a little bit so maybe you can see a little bit better. Change the value of what's on the right-hand side of this little minus equal sign. This is what's called an operator. This is what we call a decrement operator. We're de-incrementing this property by the value over here on the right. So if I do minus equals 2 or something like that, then this is the same thing as reducing the y value by 2 every tick. So when I click play, you'll see there it goes, wee, just slowly going off. Goodbye. They grow so fast. Anyway, goodbye, laser. All right, it's gone. Very cool. That worked. Hopefully it worked for you. It's quite simple, actually. But what we've done here is we've created, this is like a sin. This is like a game development sin. What we call this number that's just floating around here out in blue is a magic number, a magic number. So those of you who aren't familiar, a magic number is a number that you're using somewhere inside of your code that has no description. Like, sure, you can infer that at this situation, has to do with modifying the speed. But guess what? What if you want to use this later? What if you're going to use the speed to also change the position of something else? What if you're trying to change the speed based off of some kind of condition? Well, this magic number is just going to, you can't just change it here and then expect everything else to change. That's why you want to use variables, okay? Whenever you have something like this, you should shudder a little bit and think like, okay, I need to make this descriptive and scalable. Scalable meaning that I can make my game bigger and I can use the speed variable in different places, adjust it, modify it, change it, reuse it, and it all stays inside of the speed variable. It makes it so that I can I don't have to be locked down to this little 2 number that's just arbitrarily in the middle of our code base somewhere. So I'm going to create a variable and I'm going to call it speed, and I'm going to set it to that 2 value. So if I change 2 to speed, you'll see that the same way as we did with the player by creating what we call a local variable, we can then use the local variable wherever you want. When I say local, I mean that this is a variable that exists inside of this function and only this function. If I create another function elsewhere, this variable doesn't exist there. It only exists inside of this function body. All right. Very cool. Now if I hit play, you'll see that it still hopefully works. Hey, look, it goes. Very, very neat. We have another problem, and I know we're stacking a lot of the concepts right now, right here, but this is going to be really important and really useful to you. Hopefully you put your little thinking cap on, because we're going to talk about something that's really important. What if my game starts lagging real slow, right? This 2 represents changing the Y position by 2 pixels. How often? Every time this function runs. How often does this function run? It runs however many times, per second that the game is able to execute this process function. It depends on how fast the computer is. If the computer is running 100 frames per second, some of you already know this terminology, FPS, if it's running at a higher frames per second, then this 2 is going to be executed how many times? So this is where I'm actually going to open up this little drawing pad here. I'm going to draw this little bracket. Let's say that this represents 1 second. Okay? And if in that function, it runs, I don't know, 100 times, each of these represents a frame. So let's say this is 100 times. Okay? And let's say someone else is running our game, but it's going a lot darn slower because they're running on a TI-83 calculator or something like that. And this is also 1 second. But the frames, this, game can only run 2 frames per second on this person's device. It's the same game, but processes will only run twice. And on this machine, processes run 100 times. Okay, in this machine, well, if processes run 100 times, then that means that, well, 2, if it moves at 2 pixels each process times 100 times in a second, then it's moving up 200 pixels in a second, right? Well, in this scenario, where processes run only twice in a single second because it's running 2 frames per second, then that means that this code is going to run only twice. So it's only going to move 4 pixels in a single second. So in the same amount of time, it's going to move way not as much. So older games didn't fix this problem. This is what we call, in the olden days, we called this, let's see if I can write some text over here. Called this frame rate dependence. We want to fix this so that it's frame rate independent, so that our game's motion is not tied to how fast the computer is running. You understand? So this is frame rate dependence. I want to fix this to make this frame rate independent. All right. That's where this delta junk comes from. We kind of ignored this for a while, but this delta thing here is a variable that's automatically given to us by the process function. It's here you go. It's not a property of our node. It's just something that's specific to the function, the process function. This tells me, the delta variable tells me how many seconds has elapsed since the last frame. Okay, so if I'm on this frame here, it'll tell me how long did it take between this frame and this frame. The same between this frame and this frame, right? It tells me how many seconds it took. All right. Have you ever like met somebody who just like, whenever you arrive somewhere, they're like, you took exactly 13 minutes. And it's like, oh, I didn't know you were keeping track of time. It's like that. This is like this delta is like the function is telling you like, you know how long it took since the last time we ran this? So delta in this scenario is half of a second, because since it runs 2 times each second, that means that each time it's run, it took a half a second between frames, right? So a half of a second. In this case, there are 100 frames inside this second, so each frame took 1/100th of a second between those frames, okay? Between the executions of the process function. Now, you already are like, I thought you said this was the easiest tutorial. What's wrong with you? Well, let me tell you how to use it so that you don't have to worry too much. What we do, and this is just think of it this way if you don't understand how I'm explaining this. If you multiply something that you're changing by delta, then it will convert the value that you're setting your thing that you want to change to be this per second. Okay, so if I want to rotate something 180 degrees per second, then you set the rotation, plus equals 180 times delta. If I want to make this move 2 pixels every second, then we'd say change the Y position by that 2 pixels times delta. This delta basically means, when we do multiply delta, it means make it per second. Okay, so that's what we were trying to do here. So this is pixels per second. That's what speed represents. And when we do delta, it makes that happen. So if I wanted to move 200 pixels every second, when we multiply it by delta, then what will happen is that that laser is now going to move 200 pixels every second, regardless of how fast or slow my computer is. And the reason why that is, if you just do the basic math, is that if we're talking about 200 pixel, or if we're doing 200 times delta, well, what's 200 times 100th? 200 times 100th, that's 2 pixels. So 2 times 100 frames is 200 over the second, right? If delta is 1/2, then think about it. 200 times 1/2 is what? 100. So 100 adds up to 200, right? So it doesn't matter. Like, you can try to, maybe this is blowing your mind right now, but you can do this with no matter the frame rate. If you multiply it by the amount of time between the frames, it's always going to come out to this number per second, is how much this is going to change. All right. Again, if that was confusing to you, I recommend just try cutting your teeth a little bit more. Just multiply something that you want to change by delta and adjust that value so that it remains frame rate independent. Awesome. That's super cool. Now, now that we've done that, I'm going to do one last thing before we get into more fun stuff. One last thing that I want to show you while we're here, because it's going to be an awesome segue for some of the stuff that we're going to be doing later, which is, what if I want to change the laser's speed? What if you're the programmer and there's also a designer? Is the designer who wants this, adjust the speed, maybe based on player feedback? You want to make it go faster. You're like, oh my gosh, this laser just goes too slowly. I want it to go like twice as fast. How are they going to do it? Are they going to come to your code and change this value? They don't know how to program. All the more reason why you shouldn't have them touching your code. Okay, even if you're the programmer and the designer, that's okay. To organize this better, you want to be able to adjust this value from the editing window, not from the code window, because how fast something goes is not a programming decision, it's a design decision. So whenever you have a design decision, you want to offload it to the level editor. So how do you do that? Well, speed is something that right now is a local variable. It only exists inside a process. But what I can do is, if I cut this, so I did Control X or Command X on a Mac, and I paste it up here above the function process, what this has done is this has made this a property of the laser. So now if I save it and I do like self dot, you can see speed is now a property, just like self dot position. It's now a property of this node. And because it's a property of the node, we should be able to modify it as a property inside of the inspector. Isn't that freaking amazing? Well, where is it? I don't see it. I have the laser selected. It's not there. Where did it go? Well, sometimes you want a property to not be changed in the inspector. Remember, there are some properties that, when I do self dot, there's all sorts of properties in here, and a lot of them aren't in the inspector. So if you want it to be in the inspector, what you do is you use a this fun little thing. I'll call it a doohickey for now. This little tag, let's call it. A little X, it's called export. We use the @ sign. So that's Shift-2 on American keyboard, English keyboard, and then it's export. There's a variety of these different export things. You can watch a different video. I'm not going to cover all of these. It allows you to like make it so that you have sliders and all sorts of fun stuff. But as soon as I do export it, you have to have that. Like if you don't have that, it's going to get mad. It's going to be like, well, what the heck are you talking about? So if you have that little @ sign, now when I save it, you can see, ta-da, it should hopefully work for you. But the speed right here is now available inside of my inspector. So now when I change it, see, I don't even have to be in the code window at all. With laser selected, I can change speed to 400, save it, hit play, and you'll see that, oh, it didn't change. Or is it? Did it change? Oh, I didn't hit enter. Guys, you gotta hit enter. Folks, you gotta hit the enter key or return key. It's funny how it let me hit play without like hitting enter. There it goes, double the speed. Double the speed. Very cool. But you'll also notice that we have this little curly arrow. The curly arrow says return the value to its default. The default we set is 200. So if I hit this, it'll jump back to whatever the default was inside of the code editor. Very cool. So I hit save, and then I hit play. Again, it's going 400 pixels per second. So cool. All right, very cool. Hopefully that made sense for you, because we're gonna move on. I'm gonna take a sip of water. A tall glass of water. What the heck are we doing? Let's make it so that we can spawn these lasers, right? Because right now it's, when we hit play, it just goes. But I want to be able to make these lasers. All right, so we're going to spawn the laser. The question that we have to ask is, well, similarly to all the other interactivity in our code editor, we kind of pseudocode. We stop for a second. Otherwise, you can get very quickly overwhelmed. Sometimes you can even use it like a pencil and a paper. We decided, okay, well, how often should the player move every tick? So that should be in process, right? How often should the laser move every tick? It should be in process. Well, with the laser node, we want to spawn the laser node. So we want to ask the question, well, how often should the laser node spawn? Well, not every tick. That would get out of hand. I guess there are some shoot 'em ups, that it just like spawns every tick basically. But I don't want it to spawn every tick. I want it to spawn when the player clicks their mouse or something like that, or the player taps the screen or whatever it might be. Okay, well, cool. But how do you do that? Where do you do that? Again, if you're coming from like Construct or one of these other types of like, monolithic single code view type of thing, you would just all do it in like one big main script. So where would we do this, right? And that's actually a really good question. It's one of the core questions that programmers always ask themselves. Where am I going to type this code? Well, in this case, we want the player to shoot the projectile, right? And we want the projectile to be at the player's location, and we only want the projectile to be fired if the player exists, right? If the player is destroyed, we don't want to shoot the projectile anymore. So it's reasonable, and sometimes you just got to go in, you can change it later, but it sounds like a reasonable place to put it in the player script, right? We don't want the laser to spawn lasers. That would get a little trippy. Lasers spawning lasers every time you click, that would be kind of neat. I don't want to do that. I'm going to go to the player script. So I know I want to put it in the player script, but when do I want it to happen? I want it when the player clicks. Well, how do we do that? There's a couple of different ways to do that, but I feel like the most intuitive for a beginner is to just think of it in terms of how often are we asking the question, has the player clicked? Has the player clicked? Has the player clicked? How often are we going to ask that question? Well, we want to ask that question all the time, because any moment of the game, we want the player to be able to shoot a projectile. So that's where we're going to ask. We're going to ask in the process function, because the process function runs every tick. So we can ask the question every tick. So I'm going to actually write some actual comment here so that we can pseudocode this. Pseudocode, okay? That's pseudocode, right? I'm going to type it out. So what I want to do, so player clicks and then spawn laser, right? That's what I want to happen. So let's work on each of these sequentially. Let's start with player clicks. How do we check to see if the player has clicked? Well, the best way to handle that inside of Godot is to create an action for the action that we want to create. It's called an action inside of Godot, and we can set, just like how in a game where it's like, I'm going to go to my controller map and say like, I want jump to be A. No, I want jump to be right trigger because I'm a pro gamer or whatever, right? We click on project settings. You can adjust what actions are bound to what keys or mouse clicks and buttons and things like that in your project settings. So in the project settings, I know a lot of times project settings is kind of a scary place to go, but in Godot, this just should be considered just a wing of the engine. It's just something that you're going to jump into very often. You don't have to worry about all these other settings. There are a couple of settings that you go to all the time, and that's the input map tab is one of them. Okay, so don't get afraid of it. Just dive into the project settings. You're not going to have any problem. I almost want it to be somewhere else, but the project settings is really a good place for it. The input map tab allows us to create a new action. So under add new action, call it whatever you want. You can call it fire laser. You can call it shoot. I don't care. I'm just going to call it fire. Okay, fire. And then I'm going to click add or just hit enter. And you'll see that I've created an action. It's called fire. Now I want to bind some kind of input to that fire action. And I can do that by clicking the little plus icon here on the right. If I click on the plus icon, it'll say like, okay, when does this fire action occur? Well, I'm just going to click on where it says listening for input, and it's going to say, okay, left mouse button. That sounds good. Very cool. I'll click OK. And you'll see that fire is now associated here with this left mouse button. I can click on the little plus icon again because you know what? We can bind multiple keys to the same action. Maybe some players like hitting the space bar instead of the click. So if I click on this little plus icon again, I can hit the space bar key and it's going to say space or space physical or space Unicode or whatever. Just go ahead and click OK. After listening for that, we have the left mouse button and the space key. They're both associated with the fire action. You can have the space bar associated with multiple actions if you like, but specifically the fire action, space is one of the accepted input commands, let's say, that will trigger the fire action. I can go ahead and click close. It automatically has saved for me. I can click close. So now that we have created that action, how do we check if that action has happened? I'm going to go ahead and just do it right under this little pseudocode comment. We are going to use a question that is built into what is called the input class, okay? You can just call it an input thing. I don't care. It's a class. I know the word class maybe doesn't mean that in your brain, but that's what I'm going to say. This is the input magical object, we'll call it. It's the input class. And then I go ahead and click dot, similarly to self dot, or get global mouse position dot, or whatever the heck it is. Dot allows you to access a property of that object. The input object is this global object that you can access from any script, anywhere, anytime. You can access this input object. It's capital I, which means that it's a class, and don't worry too much about those details. You can take some computer science classes if you want to learn more about that, or watch one of my more advanced videos. Click dot. Well, what are the cool stuff that the input object allow me to do? And one of them is you can just type in action, and you can see that here are the variety of things associated with actions, including is action just pressed. So if I clicked action just pressed, is action just pressed, it'll then ask me, which action are you asking has just been pressed? And you'll be like, wait, what the heck are all these other actions? I don't remember making those actions. Well, those are built-in actions. And I'm not going to go back to it right now, but in the project settings and the input map, you can actually unhide those so you can see those built-in actions. But the one at the very top is the one that we created, our custom action here. So fire, if I double click on that, very cool. So this is the question we're asking. Input is action just pressed. You see that? That's pretty cool. In fact, if you wanted to, you could even print the result of asking that question. So if I hit save and I hit run and I look inside of my little thing, it says false, 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 false. But if I click, you'll see that it kind of is disrupted. You'll see a couple trues in there every now and then. True, 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 true. right? Because some of those process frames, the answer to this question was true. It wasn't false. So how can we make use of this question? Well, we can use what's called an if statement or an if structure. We use the if keyword. When we use the if keyword, then whatever this condition, so this question, whenever it's true, then we're going to use a colon, just like how the process function has this little colon. Whenever you're going to create what's called a code block, basically a block of code that is meaningful to this particular structure. So everything inside of here is run in the process function. Everything that's run inside of the what's indented under the if statement and after this colon is a code block that is executed whenever this condition is true. Okay, this question that we're asked, whenever it's true, or truthy, but whenever it's true, then go ahead and execute the code that's inside of this code block. And we specify a code block with a tab, this little indent. So if I type in print, I can say laser spawned or something like that, right? Very cool. Just so that, again, we're testing our code. Because if we start trying to write code that actually spawns a laser right now and it doesn't work, then we don't know if it was the if condition that didn't work or if it was the spawning code that didn't work. So just check every step of the way, especially if you're new. Go ahead and click play, and then notice how inside of the little output log here where print statements show, nothing's happening until I click. And when I click, it says laser spawned, laser spawned, laser spawned. Every time I click, laser, 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 laser spawned. Okay, very cool. Because this code block will only run if this is action just pressed is true. Very cool. So now we know that we can replace this print statement with the code that actually spawns the lasers right here. Awesome. Okay, hopefully that makes sense. So let's go ahead and figure out how are we actually going to spawn a laser, because we already have a laser. What are we going to do? Duplicate the laser? Actually, yeah, that's basically what we're going to do. But we're going to duplicate the laser in a much more fancy way. Now, you can duplicate the laser by selecting on the node and clicking Control D or doing Control D. So look, I've got 3 lasers. All of them have the same script attached to it. I didn't duplicate the script. They just all are pointing to the same script so that when I hit play, they all behave the same way, right? They all are going up at 400 pixels per second. Very cool. That's how I duplicate the laser inside of the editing window, but I want to duplicate it inside of the code window. Now, there is a duplicate function, but I don't want you to use that. There's something far more powerful and far more fundamental to how Godot works that you're about to learn now. And I want you to put your thinking cap on, because this can get a little tricky, okay? This can get a little bit tricky, what we're about to do now. I'm going to go ahead and delete these other couple lasers. I'm going to keep one of them, because if I delete the other one, I'm going to have to redo some work. The node tree looks like this, okay? I'm going to do this relatively quickly. I don't know, shapes. I'm still getting used to this. All right, very cool. We have our main node. Main. Ta-da. And then I'm going to go ahead and duplicate the main node. And we have player. And then I'm going to duplicate the player node. And then we have, what, the ship graphic or something like that. And then after that, we have the laser node over here. Laser. And then we have underneath it, we have what, the laser graphic or something like that. Right, so this is what we have so far. It's really pretty basic. And then we have these kind of like lines that connect each of these nodes. And it, you know, comes down here like this, and then it comes over here like this. So that's how our tree structure works right now. And there's also like a background graphic. Don't worry about that. So how does this work though? Okay, what do we want to do? Each of these nodes that we have here, laser graphic, they're connected to a parent node, right? That parent node is main in this case. Main is the root of this particular scene tree. This is where it's really, really trippy, and I want you to pay close attention. What I'm going to do next is I'm going to cut its connection, the laser's connection to the scene tree. Why did it delete both of these? How are they connected? Okay, I'm only going to cut that connection. Hello, draw this line again. Okay, I'm going to free it from the main tree. Whoop, so it's over here. And I'm going to make this its own tree. You know how there's something called grafting? Like frickin' clementines are named after some like Algerian dude from like the 1800s who like came up with a tree, and then we've created a clone of that tree every single time. Like anytime you eat a clementine, you're literally eating the exact same genetically identical clementine that like old man Clementine from Algeria made in like the 1800s. Okay, because they're exact clones of the original clementine tree. And it's the same thing what we're going to do right now. We've separated this out and we've cut this branch, and it's now its own tree, because you look at it, a branch is just a tree, right? Now the branch is the trunk. All right, that's what we're going to do. We're going to make a totally separate tree, a totally separate scene file from the main scene that's going to encapsulate the laser. And whenever we want to make a laser, we're just going to duplicate the laser scene and put it back inside of the main scene. And we're going to duplicate the laser scene, we're going to put it in the main scene. We're going to duplicate the laser scene, we're going to put it in the main scene. Every darn time we want to make... Oh darn, I've kind of screwed this up. Let's undo that a couple times. And so yeah, and then we're going to add this back to the main scene. So we have this as a template, its own separate tree that's saved elsewhere that we can clone and put as a template inside of our main scene whenever we want it. That's what we're going to do, okay? So very cool. This is one of the most confusing parts of Godot, but if you understand this, then you're like a Godot hero. You will be a master Godot, a Godotician in no time. All right, so hopefully it made sense. All right, very cool. So to do this, to elevate this laser to more than just a branch of the main scene, I'm going to right click on, again, the main node. Please do not do this to the child node. You are going to make your life hard. It is not easy to fix it. It's a lot more annoying to fix. Don't do it to the child node. Do it to the root node of the laser. All right, I'm going to right click on laser, and I'm going to choose save branch as scene. Save branch as scene. Again, please don't right click the graphic. Right click laser, choose save branch as scene, and it's going to say, okay, well, we already have a main TSCN file. Let's make a laser TSCN file. Again, it's now going to be just like the main scene. It has its own root. If I hit save with the default, again, it's now shows up here as laser.tscn. It's now something that exists in our file. And we can click on this little scene. It looks like a clapboard or something like that. If you if you just single click here, right here, it says open an editor. You'll see we have a new tab, main and laser, main and laser. Okay, and if you look at the laser scene, it, like the main scene, has a root of the scene, which is the laser scene. It's its own node. Holy moly, it's its own tree. This is the crazy beauty of Godot, and what separates it from just about all the other game engines. And why a lot of people really like it, because it makes it so flexible. All right, and so here's our laser off in the middle of nowhere. Do not add another space graphic to it. The space graphic's already in the main scene. Don't add another one to the laser scene. Okay, the laser just exists off on its own with laser-only things that have to do with lasers. Very good. All right, it still works the same way. If I hit play, then it still runs. Except here's the thing. When I duplicate these lasers, like I had done before, I've done something far more powerful than what I had done before. Because now what I've done is I have not duplicated the whole branch of the main scene. I've created what we call instances of the laser tree. So what that means is that if in the laser tree, this is the template, remember? This is my original branch. This is the one over here, the one from which I'm copying all of my laser instances. If I make a change to the laser template, which is this laser TSCN file, such as, I don't know, let's make it like 3 times bigger or something like that. Just make it like real big. When I come back to the main scene, if I save this, you'll see that in the main scene, my lasers are now 3 times bigger. Do you see that? All of them are 3 times bigger because we have modified what it means to be a laser. Okay, not just that laser, what it means to be a laser, because that's what the scene tree, this laser.tscn file dictates. All instances that derive from this, are cloned from this tree, will get the same default properties. And when I say default properties, I'm actually going to come back in here and let it be big. It's just the default properties. I can come back in here and change the lasers individually. See, notice how I can come in and I can change this back to be like 1.5 or something like that. And this particular laser is smaller because once it's been born, you can change it. Just like human beings are all born with like, you know, okay, this could get political. I don't want to get into that. The point is that these all clones, let's say a clone, a human clone, which is also political, dang it. But all human clones are born with exactly the same, aspects and characteristics and properties. But after they've been born, you can do whatever you want. You can like chop an arm off. You can, one can grow faster than the other one depending on what you feed it. The same kind of deal. These are all ones that have been born from the clone. They've been cloned from that scene template, and you can modify them. You can, what we say, override their defaults, or we can return them back to their defaults. Okay, does that make sense? Hopefully, if I save, these are the default characteristics, and we can change them. Notice how each of them have their own positions. They all have a different position. So yeah, those properties can change, override over the default properties. Cool, hopefully that made sense. So what I want to do now is I want to now figure out how I can do that in the code. I just learned how I can create a copy of that tree in the scene editor. I want to create the copy inside of the code. So I'm going to come back to my player, and right here where it says laser spawned, I want to learn how can I create a copy of that tscn file inside of my code. Well, to do that in the editor, all I had to do was like copy it here. And also actually, if I come back up here to where I'm going to smallify this little lasers thing, you see laser.tscn? If I just click and drag laser.tscn into this little viewport, you can see that I'm able to like drag as many copies as I want. See, here's like laser 5. Where did it go? Where are they? They're somewhere. Why are they all the way down here? Oh, I know why they're all the way down there. We'll talk about that in a second. But notice how I'm making them. I'm adding them by just clicking and dragging laser.tscn into the editor. Well, how do I do that in the code? Well, I got to bring the laser.tscn file into the code. That's what we have to do. How do we bring the laser.tscn file into the code? What we can do, this is the easiest way to do it. Inside of the player script where we want to be able to create the copy of the laser, I'm going to create, just like we did in laser, how we exported the speed variable so that we could change set its value inside of the inspector inside of the editor. I'm going to export a special kind of variable. A special kind of variable. This variable, the same thing as before, just like this, just like export var speed, we're going to do export var laser tscn. By saying laser tscn, it's reminding me that this is the tscn file. But notice how it's mad at me. It's like, hold on, you can't export something unless the editor knows what type of thing it is, right? Because over here in the speed, notice how we can click like up and down. How can we do that? What if it was like a string like hello? Like what would up and down mean for hello? That doesn't make a lot of sense. The way that it knows to be able to allow you to type in a value here, right, is that it knows what type of data it is, right? This is obviously a number. So what Godot has done is has inferred that this is a number. But here's the thing, when I click up and down, why isn't it going to 400.1, 400.2, 400.3? In fact, if I typed in 400.1 and I hit enter, you'll see it just jumps right back to 400. And if I do 400.5, it jumps to 401. What the heck? What if I want it to be some kind of decimal? We've got some designers who are like really specific. They're like, 400 isn't perfect. We want it to be 400.3. Well, here's the thing. It inferred that this was a whole number, or what we call an integer inside of computer programming. So if we wanted to infer that this is not a whole number, but a decimal number, is we would say, 200.0, for example. So therefore, right here, we can say 400.1, and notice how we're able to do that. See, I'm able to type in 400.1, 400.2, because by doing .0 like this, it infers that, well, this is a floating point number, a floating point number. So if we're like, okay, hold on to our horses. I don't want to type 200.0. I just want to type 200 because it seems a little contrived to type in a .0. I just want to tell the editor manually that this is a floating point number. I can do that by simply using a colon and saying what kind of value it is. So if I just say float like this, var speed colon float, I'm saying this is the variable name, speed, and it is a float. So now when I hit save, and I didn't use the little decimal point here, I can type in 200.1 and it allows me to do that. Because it's no longer inferring over here, because I'm explicitly telling it that it is a float. Okay? I'm explicitly telling it it's a float. This is what is called static typing, where we are choosing the value for the variable. You don't have to do that. Notice how before I didn't have to do that, right? I did that and it worked fine. But sometimes you want to be explicit about it. You can be explicit about it wherever you want, whenever you want. Okay, you can be explicit about it whenever you create a variable. But in this case, we do want to be specific about it, because what's it going to infer? Laser.tscn is what? I'm just going to like start typing a bunch of like weird like code and stuff. I'm going to type in the actual like contents of the .tscn file, this like giant file of like settings and things. No, like no. That's why we're exporting it, so that we can drag and drop it. So in order for the editor to know what kind of value it can set that property, we have to explicitly specify what it is. Well, what is it? And I saw someone said Skepsis, that's a cool name, in the chat. Packed scene, that's what it is. It's not just a scene, because this is a scene, right? The scene inside of the actual editor is right here, in the game is right here, you know, when we run it. A packed scene is the file. It's the file that has packed the scene, so that we can save it, we can close Godot, we can reopen Godot, and it's taken that scene that's been packed into a .tscn file, right? So it's a packed scene. It hasn't been loaded yet. Very cool. So once I've done that, it stopped yelling at me. And if I click on player now, you'll see that laser.tscn is now an option over here, and it's not allowing me to type in like a number anymore. It wants a packed scene. So, well, how do we give it the packed scene? The same way we give it a sprite. Okay, sorry, not a sprite, a texture, like the, you know, sprite graphic, the ship graphic and so on. So I'm going to click and drag this laser.tscn file because it is a packed scene. And notice how it has a little no smoking sign, but as soon as I hover over that empty, it's going to say, oh, that's what I like. That's a packed scene. When I let go of it, there it is, the laser.tscn file. Very cool. So not only do we now have access to that tscn file in the code version of the scene, the packed scene, that tscn file, but we were able to specify which scene by clicking and dragging it right there inside of the editor. This is how you're able to spawn objects inside of the Godot code. So get used to this. You're going to do this a lot. All right, very cool. So how are we going to create that instance of the laser scene? We do it by first referring to the tscn file, right? The laser_tscn. Now you could have called it anything you wanted. You could have called it laser_scene_file. You could have just called it, you know, my laser file. I don't care what you call it. It doesn't matter. It's just a variable name. But in order to create a clone of this tscn file to make it make it born, right? To give birth to it. Oh golly. We can use the dot operator is what it's called, the little period, and we can access properties and also functions that belong to that object, the laser.tscn object. So laser.tscn, I can type in inst, ins, and you'll see instantiate right there. Instantiate is the function name, instantiate. When we do laser.instantiate, you can hover over it so it tells you more about it. Remember, if you hold Control and you click, it'll tell us more about it. See, it's a property of the packed scene, and it tells us like it instantiates the scene's node hierarchy, blah, 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 blah. Again, that's not necessarily very obvious. They use very technical terms, so I'll try to help to explain it. What it gives us back, by running this function, it creates a clone, a copy of that laser file. Here's the problem. If I run it, and remember, we know that the clicking works, but nothing happens, right? Those two were not from me. Those two were those like laser 4 and 5 that I created from before. See, nothing's happening. What the dumb? Actually, I'm going to delete 4 and 5. They're driving me nuts. Right? It's not making new lasers. It doesn't appear to be making new lasers. Here's kind of the really odd thing about Godot. You know, I didn't design Godot, and this wasn't designed entirely with like total beginners in mind. But once you get a hang of it, it's fine. What you've done by doing laser.instantiate is you've made it exist into the ether world, right? It's like it exists in a way that is not concrete. It's like this abstract notion of a child that hasn't been born yet, okay? It's like it exists within this like weird reality that isn't quite there yet. It's in memory, it's just not in the game yet. In order for something to exist inside of the game, for Godot, it has to be in a scene tree. It has to be in a scene tree. Right now, what I've done is I've basically said, make a copy of this. And I did it. It was like, here's a copy, but it's just like floating around and it's not attached to the scene, right? So we have to make it part of the scene or else it doesn't exist. You understand? It exists in memory, but it hasn't been born yet. So that's what we need to do. How do we make it born? Well, we're going to use a function that gives birth to it, so to speak. And the most common function that we use is add child, right? Add child. Now this is a function and it's already mad. It's like too few arguments for add child because it has to know what child is being born. We could have instantiated a bunch of nodes, but we have to then specify which of those nodes we're going to give birth, right? To add as a child. And we want to add this. So I guess we could just like dump it in here like this. Don't do that because then we can't make any additional changes to it, right? It's born and then we can't really do much with it. So in order for us to be able to make changes to the initial settings of this cloned laser scene, we have to make it a variable, okay? So I'm going to create a variable. I'm just going to call it new laser. Okay, laser tscn is that file. Instantiate says create a new copy of that laser tree in the file and go ahead and store it inside of this new laser variable. Now that it's in this new laser variable, we can then put it anywhere we want. Basically, it's like we've given the new child a name, right? And it's not really its name as we see it in the tree. It's just kind of like a little nickname that we're using in the code temporarily so that we can make changes to it now that it's born. So we can say new laser, right? So we can say add child new laser, and that will make it born in the tree. Well, I'm going to go ahead and hit play, and I'm going to click. Huh, doesn't seem like anything's happened. Wait, nope, there it is. And wait a minute, what is it doing? Why is it like, okay, I'm just going to create a bunch of them. Maybe that one was defective. That child was defective. No, what? I'm making a lot of them, but they're attached to the player somehow. What's happening? Okay, so what you what's happening here? The best way to be able to really grasp what's happening here is this awesome feature of Godot, and I really want you to understand this. What we see here is the tree, the main scene tree before we hit play. Remote, which is a really interesting name, it's not intuitive to a beginner, but remote means basically the live tree, the tree that currently exists in the game that we're currently running, we're currently debugging. If I click remote, you'll see this is what the actual tree looks like. Wait, where are my lasers? Laser, 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 those were the ones that were from the start, but if I click player, you'll see, whoa, whoa, wow, wee, there's my lasers, laser, 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 and if I click on them, not only I'm able to see what the, what these things are, but we can also see their properties update in real time. Look at it, it's at like negative 13,000 and going, right? It just keeps going and going and going. And now when I'm back in my thing over here, I can kind of look carefully. When I click and I click, you'll see now I've got 14, now I've got 15, now I've got 16, and you can see that in real time, we can see our tree evolve. But isn't this awesome? We're able to see our scene tree just like, get all these new clones and these children that we've created from our laser scene. So that's really exciting. It's not exactly what we want, but at least we know something's working. This is what I want you to understand. And the reason why I think it's useful to sometimes to go the extra mile to type self dot every time. Because when sometimes you kind of forget that when you're just typing in properties and functions, who those properties and functions belong to, right? The instantiate function belongs to the laser scene. What the heck does the add child function belong to? it belongs to self. Remember, by default, when you type a property that already exists, you didn't create like a new variable or anything like that, that function or property could very well belong to the object. It doesn't always, right? Like that input function, this little input thing, and I click on it, it doesn't belong to anything. It's global. It's something that you can access anywhere. If you did self.input, it wouldn't work. In fact, I'm curious to see if it would try to work. Is it self.input? It's probably going to get mad. Or not. That's interesting. This input doesn't belong to this node. This is just like this global thing in the middle of nowhere. It would probably get mad if I did more with it. Perhaps. But this is particularly relevant to add child. Because when we say self.addChild, when we do add child, what we are doing implicitly is just shorthand for self.addChild. So who's giving birth to this child? The object that this script belongs to is giving birth to the child. And that object is the player node. So when we just say add child, like, carelessly, we are adding child to itself. We're adding that laser to the player. And as we saw earlier, when the laser is a child of the player, it moves with the player, and that's not what we want. We don't want to add it as a child of the player. So who do we want to add it as a child to? That's a good darn question. And the correct answer is not, there's no one correct answer is what I'm trying to say. We just know that we don't want it to be a child of player. We want it to be maybe a sibling of player. Well, is there a way to add the laser as a sibling? Well, let's try add underscore. What is that? Add sibling. That's kind of cool. So I'm going to do that. So add sibling is shorthand for get parent dot add child. Okay, that's what we like. If your kid ever is like, hey, can you like, add a child for me? Ask your parent, can you add child? That's what add sibling is. It's just shorthand for add. Just get parent node add child. And you add a sibling. So this is how we can add a sibling to the main node. Now we want to be careful with this whole idea of siblings and getting parents, and we'll talk more about that in the advanced insights at the end of the video in the Q&A. But for this, that's not actually a big deal because these lasers are already siblings of the main scene. So now when I click play and I go ahead and run this, hey look, ta-da! It's no longer like attached to the player ship, but it's like inexplicably just like appearing in like this weird location right here. I want it to spawn at the player's location, not over here. Why is it spawning over there? Well, if you remember carefully, if you look at the laser scene itself inside of the editor, that's where it's located by default. If I click here and then I look at the default, remember, when it's inside of the TSCN file, these are what we have stated are the default settings, the default properties, default property values of this scene. And the default is this 147.796 business down here. So that when we add it as a child, it's going to keep that 147.796 property, position. Whenever we do add sibling, whenever it's born with that position. And when it's added as a child of main, well, what's 147 by 796 with respect to main? It's that specific location. Well, I don't want it to be 147.796, but that's why we created this darn variable, because now we can change. We can override those defaults I had mentioned before. So I can say new laser dot, just like we say self dot, because we can access the object with the dot operator. And what do we want to change? Just like self dot position, we can say new laser dot position. So cool. Well, where do we want this laser to come from? Well, we didn't want it to be a child of player, but we still wanted it to start at player. So we're going to set it to self.position. So now when we save it and we hit run and we hit shoot, it spawns right there at the player's location. And now we can like really get some repetitive strain injury by creating a whole lot of these darn things. All right, very cool. That's kind of neat. Hopefully you understand and see how that works. And that's why I like saying self dot, because it's clear. If we say new laser dot position equals position, like when you look at that, you're like, yeah, duh, position is equal to position. Like, what are you talking about? Well, we're talking about self dot position. That's what we're talking about. So position.x is the same as this self.position, right? Or position, when we say position.x, is the same as position when we say self.position, okay? I'm just going to keep it saying self.position because we're being explicit here, but we didn't need to do that. It should still hopefully work. It should work either way, whether or not you write self. I love that you're asking questions. Hopefully you can answer each other's questions for now, and I'll come back through again because hopefully there will be a lot more people who are going to be watching this video down the road. Already getting a little hoarse. I'm like a horse. All right. What are we talking about? Because this is works, right? So now let's make the darn ship, the enemy ship. In fact, you can like pause the video if you want. Well, I guess it's a live stream, but if you're watching it not as a live stream, you can pause the video and just kind of, practice on your own. Go ahead and make that enemy ship. You can do it. I know you can because it's really the same thing as we had already done. All right, so go ahead and keep doing that. And while you do that, I'm going to clean up my scene a bit by deleting these extra lasers that have been instanced onto the main scene. And there's the original laser. So you might be like, no, don't cut down the original clementine tree. You'll ruin the clementines forever. No, we've already made the like freaking, template clementine trees. So even though there's no laser, instance in the main scene anymore by default, we can just still spawn as many as we want because it's saved inside of that TSCN file. Very cool. In fact, I want to like make those lasers go faster by default. So inside of the laser.tscn file, I'm going to set 400 to be the default. So now whenever I hit play, it's going to go with that default instead of 200. And again, I didn't have to go to the code to do that. The designer can do that. I'm going to go ahead and do this enemy ship thing. So just the same way as I did with laser, I'm going to come to main. I'm going to click the little add a new node. I'm going to make it a node 2D because this enemy ship might have collisions, probably it will, and other fancy stuff. So I'm going to go ahead and click create, and I'm going to change the name of this node to simply enemy because we live in a black and white world where we just have enemies. Yay, we're going to kill enemies. Yeah, let's kill them. Anyways, that was somewhat facetious. All right, let's go ahead and create a sprite. Sprite 2D, and this is going to be also a ship graphic. In fact, it has the same name as the player's ship, right? Graphic, but it doesn't matter because they're each children of a separate parent, so it's not going to have any name conflict. What's going to be the ship graphic for the enemy ship? Let's do a player ship because you know what? Ha 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 ha. I don't know, this green one here, player ship green 2. Very cool. I'm going to go ahead and with the ship graphic still selected, I'm going to make it, I guess, a little bit smaller. I don't know, 0.6 or something like that. It doesn't really matter. And for the position, we're going to keep it 0, 0. For the offset, we're going to flip the vertical so that it's facing down. And before I make the not so grave but common mistake of moving the ship separate from its parent, I'm going to select the enemy parent, and I'm going the node 2D, and I'm going to click the little handcuffs thing so it can't move from its parent. And there it is. There's our enemy ship. We can hit play just to see what it looks like on the screen to make sure that its size, it looks good. It looks pretty good to me. And I want it to go down. So just like with the laser, I'm going to do exactly the same thing, but I'm going to make it go down. Fairly certain you can change most of the node settings before adding it to the scene tree. Yes, you can. Again, I don't want to go too much into that right now. Again, I'll save that stuff for the later. You can do add sibling after you set the position because once it exists in memory, you can do whatever the heck you want with it. It just doesn't exist in the game yet. Okay, it exists in memory, so you can change its settings. All right, very cool. I'm okay with slowing down just for a second, just so some of you can kind of catch up a little bit. But enemy, I'm going to create a new script because again, nodes are big kids and they can handle themselves. With the enemy script, we're just going to go with the default, enemy.gd. Going to go ahead and click create. Again, this time, I don't really need to delete the process function because we know we're going to keep it. I don't like all these extra comments, though. Anyways, what did we do? Well, let's remember, if you need to, you can always go to the laser scene as a reference, and you can be like, oh, okay, I changed the Y position. Cool. And I changed it by the speed times delta, and the speed was a what I don't think I gave you, I said it was a property. Another name for this is a member variable. It's a variable that is a member of this object, okay? A member variable. It's a property because we can modify it outside of this object, like in the inspector. Outside of the script, like the inspector. Anyways, I have to get into all the pedantics. I'm going to come back to enemy, and I feel like I've remember it well enough to start working. So export, we're going to create a variable. We're also going to call it speed. We're going to set its default to 200 perhaps, and we'll say that it's a float because you know what, why not? You don't have to do it. In fact, I'm not going to do it, just to show you that it doesn't matter. You can do it or you cannot do it. So if you want to look at this later in the future and be like, wait, why is that say float and that one doesn't? Didn't make a difference. You don't have to specify a type. So with enemy, some people will be like, it's faster when you do a type. It's optimized for speed. It's like, okay, well, cool. In fact, I challenge you. Just go ahead and do all your whole thing without any typing, any static types, and then check the frame rate and check the frame rate with the types. I doubt you'll see much of a difference. Just do whatever is the least confusing to you. You can always adjust later. And what are we going to do? Self.position.y, but we're not trying to make it go up, which is subtracting the y position. We want it to go down, so we're adding the y position, and we're going to add it by the speed. But very easy to forget. Got to multiply it by delta so that it's the speed per second. Very cool. Now when I hit run, just to see if it works, it does. It's going down, but when those lasers overlap the enemy ship, nothing happens. When the enemy ship overlaps the player, nothing happens. So I think we've got some things to do. There's two things that we can do right now. We can either spawn the enemy ships instead of just having one enemy ship, or we can destroy the enemy ship. And since we're just, you know, we're already calling it an enemy, and we've already learned about spawning, the natural thing to do is to destroy the enemy. Let's kill it. All right, we're going to learn how to destroy the enemy. Sorry, I'm being so creepy about that. That's what we're going to do next. So let's figure out, how do you destroy this enemy ship? Well, we have to create a scenario where it can be destroyed. We don't want to just say, like, click and then every enemy gets destroyed. There's no fun in that. We want to make it so that it's destroyed when. That's where you stop and you think, otherwise you get overwhelmed. Take out a piece of paper if necessary. Stop and think, okay, when does it get destroyed? It gets destroyed when it touches a laser. That sounds good. Okay, when does it touch a laser? How does it touch a laser? Yeah, you're getting ahead of yourself. When the enemy ship touches a laser, destroy the enemy ship. That's what we want to do. All right, but here's the problem. So far with process inside of player, we said check every tick, every frame to see if the fire button has been pressed and the fire action has happened. So should we check every tick if the laser is overlapping the enemy ship? Kind of. That's a good way to think about it, and you can do it that way. But there are easier ways to do it in Godot, and that's what I want to talk about right now. We're going to learn a lot of things along the way. So how are we going to do this? First of all, unlike other game engines like maybe Construct or GDevelop or something like that, where sprites always just automatically come with like hitboxes and stuff, that's not the case in Godot and some other game engines. This ship graphic is just a sprite. It's just a texture. It's a collection of pixels. That's all it is. Okay? There's nothing magical about it. And that allows Godot to remain extremely lightweight and not use as much memory. This sprite that represents that space background, it doesn't need to collide with anything, so there's no collision anything related to it. So whenever you want something to be able to touch something else, for something to happen when this object overlaps another object, we have to do an extra step. And this is where I'm probably going to have quite a bit at the end in the little like advanced kind of QnA and insights and things like that, because there's so many ways you can handle this at this point, and that's why I want to help you. I told you that this was going to be an easy tutorial. It is. I still expect this to be like the easiest tutorial, but there are so many ways to do it, and some of these ways will really get you in trouble. And we'll talk about those other ways later, but I want to show you the way to do it that I think will be the least likely to get you in trouble. So let's go ahead and do this now. Sometimes you have to do what's called refactor. Refactor means to not necessarily fix a bug. It just means to modify an existing code or existing settings inside of your project. So for example, by me coming in here to enemy and like saying that this is a float, what I'm doing is I'm like refactoring my code a little bit. Or changing the variable name because speed doesn't make sense anymore or something like that. That's refactoring. So what I'm going to do here is I recognize that before I felt it was fine to just create a node 2D that had a sprite graphic child. Well, now that we're at the point where we're doing collisions, I recognize that we're going to have to do something with the node structure to make this work. There's some kind of node. And that node, by the way, is called area 2D. Don't make this as a child yet. See, a region of 2D space that detects other objects entering or exiting it. You might not have thought intuitively that the word is area 2D. You might have thought collision object 2D, but collision object 2D is not concrete. You can't make it. It's abstract. So we have to make an area 2D. But we could make this a child so that that child area is what's detecting the collision. And that's what you might think to do because it's like, you know, the ship graphic is a child. But in this case, it will make things easier to not make the area a child of enemy, but to make the enemy an area 2D. Okay, right now the enemy is a node 2D. But we can change the type of an object after the fact by simply right-clicking on it and choosing change type. You want to use this sparingly. You want to kind of think about this before you do this, but this is one of those kind of trust me's that you don't know why I'm going to do this until way later. I'm going to change this so that it is an area, and that's okay. Because, you know, when you're making a platformer or something like that, there's something like a character body 2D, and that's typically recommended to be the root node of a player object or something like that, or a enemy, you know, platformer character object or something like that. And that's fine. Or a rigid body 2D is usually recommended to be the root type of a physics object, like in a game like Peggle or something like that. And similarly, I'm going to make the enemy itself an area 2D by right-clicking on enemy and going to change type, and I'm going to make this an area 2D. So when I click on this and I do change, there's a bug inside of Godot that drives me bonkers, and it's totally innocuous. It's not going to harm your code at all or your project at all. But for some gosh hickey reason, when you change the type, it keeps the old darn type icon. The icon for the area is not that. It's supposed to look like that. Why does it look like that? That drives me nuts. Maybe if you save and I think if you close your project and reopen it, I think it'll fix it, but it just drives me nuts right now. Anyways, and you get this little like warning thing. Right now, we have created an area 2D, but Godot is a little bit trickier than some other engines in how it handles collision shapes, but it does so in a way that's actually pretty graceful once you figure it out a little bit. So just, again, put on your thinking cap. Area 2Ds are one of the types of nodes that require a child. Sprites don't need any children. Node 2Ds don't need any children. Areas need children for them to function properly. They need shapes in order to touch the things, right? The area is just like the brain. It's like the brain. It's a nervous system. The brain itself doesn't touch anything, right? You can like cut someone's head open, like touch the brain. As far as I know, I've never done it. But like the brain doesn't feel anything directly, but the brain is what you use to sense all of the rest of your, you know, nerves and so on. So we need other things. We need shapes in order for it to be able to touch the things we want them to touch. So enemy, we're going to create a child of the area 2D, and we're going to create a collision shape. So we can type in COLL or just shape. It's collision shape 2D. Don't do collision polygon 2D because typically collision polygon 2D is going to be more expensive. Do a collision shape because almost always a simple shape or a collection of simple shapes is going to be faster and sufficient. And you'll notice that even collision shape 2D has a little triangle saying this particular node is insufficient. It has a property. Like, and areas have required children, shapes have required properties, which is, again, not the most straightforward for beginners, but that's okay. It warns you, so it reminds you. A shape must be provided. Oh my gosh, do it. So in the shape property field in the inspector, you can choose what kind of shape it is. We can say, is it a circle? Is it a rectangle? Is it a capsule? We'll look at it. What does it mostly look like? I think it looks kind of like a circle. So I'm just going to make it a circle. And if I zoom in here, I can actually click and drag this little like radius modifier thing. And as we make it like a little bit bigger, you'll see that, okay, it's kind of extended past the nose of the ship. So if I were to try to click and drag up, you'll see, oops, I'm moving the whole darn node. Why? Because we've handcuffed it, right? I love that. So whoever said that, it's just like what I'm going to call it now. You handcuffed the child to the parent so we can't move it. So you can either unhandcuff it and then move it, or again, just it's probably easier to just, with the collision shape 2D selected, I'm going to go to the transform and I'm going to change the position, the Y position manually. Remember, negative like 0 and then up. So negative, what, 20 or something? That's a little too far. You can just kind of change it until it looks good. Negative 10, that looks pretty good. And it doesn't matter that like the back is over here. In fact, if that drives you nuts, you can always change it. Because guess what? And this is where I want you to understand why it works this way. You might be like, why isn't the area itself just like collision area 2D and then just the enemy, like that area has a shape property? Why don't we just do that? Well, because we might have multiple collision shapes. So imagine that we have a type of creature called a shapy fish, and I don't have my little drawing tablet, so that's okay. So here's the noodle. So here's this like weird corkscrew thing, let's say is like the brain of this ridiculous shapy fish. And it's called a shapy fish because its appendages are, you know, just like shapes. Here's like its circle appendage. Here's its like pentagon appendage, I guess, for some reason. And what? Okay, here's its square appendage, and it has, they're just like attached to each of these things. Like the brain is attached to each of these appendages. These are like the shapes, all right? The area is the brain. The area knows when these shapes have touched anything, right? But each shape can touch a different thing, and you can make them different shapes if you want. That's what's kind of cool about it. And it knows, you can make it know that it touched the square shape. So you could have an enemy ship where like its wing breaks off or something like that if you wanted to make a separate collision shape for the wing. And in fact, by default, you don't have to make it like break off a wing. If you don't like that, it's like this, you know, big old circle and it starts like creating problems actually, you know, functionally when a player is playing the game. You can make this like a circle or a capsule here, and then you can just make it like 2 rotated rectangles. So you have like 3 collision shapes that kind of fit the size, and it's going to be more optimized. It's going to probably perform faster than trying to create some like really complex like polygon. All right, very cool. This is most likely totally fine. Okay, does that make sense? And you might be like, well, then why didn't they make these separate things like a circle shaped 2D and a rectangle shaped 2D? Why didn't they just make? And the answer to that question is I didn't make the engine. Okay, like it would have to be an abstract collision shape thing that's not concrete to inherit from it so that they all share similar properties. And maybe they thought that would be messier. Whatever, we're going with what they did. So collision shape 2D, you can rename it or just keep it the same. I'm just going to keep it the same because it very quickly identifies to me that this is an area, especially since the icon's broken. All right, very good. I think you guys are helping each other out in the chat. You guys are so good. Cool. Now that we have this collision shape, we can hit play and nothing happens because, well, there's 2 problems here. One is, what's it going to touch? There's nothing for it to touch because it can only touch other areas, right? And there aren't any other areas, so we got to make some more areas. Let's make the laser have an area, right? That's a good thing because we want to destroy it. So inside of our laser scene, I switched to the laser TSCN file tab so that I can right-click laser and make it also an area. So I'm going to right-click laser, I'm going to choose change type. And again, I'm going to change the type of the laser to be an area as well. And again, it's going to remind me, you got to have a collision shape for your area or else your area is useless. Be like, okay. Now it's not going to crash. It's not going to like throw an error or anything like that. It'll just kind of work like a node 2D that has too many properties. All right, but we don't want to do that. We want it to have a collision shape. So we're going to do collision shape, and we kind of can zoom in here so that we can say what kind of collision shape do we want it to be. Collision shape with the shape property selected. What does this look like? Well, it looks awful lot like a capsule. So let's go ahead and choose capsule shape. It's not quite right, but if we kind of click and drag these little red handles. Now you can modify the red handles even though the like little child safety lock is on. because we're not actually modifying the transform properties of the collision shape. We're just modifying the area, the shape specific properties. And very cool. And we kind of drag that down. We embiggen it a little bit. Wow, it's like perfect. Makes me wonder if it's like, Kenny, did you make this somehow with a capsule shape? And this is fine. You might be like, is this like kind of like going to be not very well optimized? It's going to run on my TI-84. I think, oh no, my mic was weird. I'm sorry. Maybe it was a deep growl. I think this house is haunted. No, I'm kidding. Anyway, so this capsule shape is totally inexpensive. You can make like thousands of these capsules and they're not expensive because it's just 2 circles. That's all it is. The collision detection is just like 2 circles that are like connected between, you know, each other. The capsules are very, very, very lightweight, even on like a calculator. They don't take a lot of processing power, so capsules are fine. Very, very cool. So now our lasers have areas and our enemy ship has an area, and you can see it actually in the view itself by doing debug. If you click debug and do visible collision shapes, sometimes this helps you debug. If I see that we can actually see the collision shapes. Now they don't do anything when they overlap each other, but you can see they exist. So I'm going to come back, debug, undo visible collision shapes, just so you can confirm that yes, they all have collision shapes, they're all following their parents. Again, this is one of those things where you're able to test it, and it's awesome to test it because if it doesn't work, it wasn't some kind of weird child relationship or something kind of got moved offset from the parent or something like that. That's working. So now let's go to how do we make it so that my shapy fish is able to actually detect when it has touched some other, shape, some other area. That's what we're going to do next. Hopefully you're following along. I'm going to take a sip. Thank you all for being along here for the ride. What are we going to do? So here's the thing. So before I said, hey, you know what? If we kind of pseudocode it out, we can think of it in terms of like, well, if the enemy under process, we can say like, is touching like other area, destroy itself, right? Destroy itself. That's generally what we're trying to do, right? But we don't do it in the process function. We can do it in the process function. That's fine, but we're not going to do it in the process function. We're going to use what is called a signal. I had mentioned that nodes are the lifeblood of Godot. Signals are kind of like the this is not a very good analogy, but they're kind of like the blood vessels. They allow you to communicate between different nodes. It's awesome. Signals are amazing. They're a little tricky, but in the most basic level, they're not that hard. So this is how they work. Every node has special events that are associated with them. That is to say that there are certain situations that can occur, and when that situation occurs, that event is triggered. When I say event, I'm referring to what Godot calls a signal. All right. So with enemy selected, and I click the node tab. So notice how we've been working in the inspector tab. There's a node tab, and you can see that organized by the various types of nodes that this enemy ship derives from, such as object and node and canvas item and collision object 2D, and finally area 2D. These are all situations that can occur associated with this type of node. The one that we're most interested in are area 2Ds when they overlap other areas. Okay? Area entered, for example, if I hover over this, it'll say the signal is called area entered and it is emitted. So when I say emitted, it means triggered. So when I say the event is triggered, I mean the signal is emitted. It means the same thing, and depending on the game engine, it might be called an event, it might be called something else. In Godot, they're called signals, and the signal is emitted. The situation has happened. In this case, the area entered situation, the signal, emitted when the received area enters this area. Okay? What that means is that when it overlaps another area, it will say area entered. This signal will trigger. Okay, cool. That's all well and good, but how do I make it so that something happens when the area is entered, when that signal happens. That's where you get to write that in your code. So if I double click on area entered, you could double click on any of these. I mean, don't. You could if you wanted to for any of these if you wanted. But area entered is the one I want specifically. That is to say an area has entered this area. If I double click on it, it'll say, cool, when this signal is emitted, who should I tell? I want it to tell itself, the enemy. I want it to notify itself, all right? Enemy connecting from. That's as in to say that this is like where the signal is being emitted from. I want to go ahead and send it right here. See, I could send it to the player. I could send it to main. I could send it to anything else. I want it to just connect to its own self. And what should the function be called when that happens? I'm just going to go with the default. On area entered, I'm going to click connect. And when I do that, notice how it does all this work for me. It created a function called on area entered. I could have called it whatever I wanted to. I just went with the default so that, you know, you can follow along or compare it with other types of resources outside. And now we have this little green thing appear over here on the side. When I click on the green thing, it will tell me where this signal has been connected. This is a signal. This function is attached to a signal. We can attach any function we want to a signal, but this particular function on area entered is attached to the area entered signal, and it's coming from the enemy and it's going to itself, the enemy. Okay, so this should happen whenever an area has overlapped it. And what do we do first? We test it, make sure it works. Print, and we can say enemy destroyed or something like that, right? Because ultimately, that's what we want to happen. So I'm going to go ahead and hit play. And now when I click, or when I shoot, it says enemy destroyed. That's pretty awesome, right? It says enemy destroyed over here in the window. But that's a problem because the enemy's not being destroyed, right? In fact, you can see that every time an area overlapped it, it says enemy destroyed. It doesn't just happen once. Any time that situation occurs, that signal is emitted, area entered. Right? Every time area entered happens, that signal is emitted and it will notify, is what we say, anyone that's connected to it. And in this case, on area entered, that function which is attached to itself is connected to it. So very, very cool. Now we know that this works. This is where we want to type our code is touching other area, destroy self, right? We want it here. Well, we've already handled this part, that is touching other area, because that's what this on area entered is doing for us. Instead of having to go inside the process function and say like, is the area like overlapping? And then you'd have to like have a list of all the other areas. Is it overlapping this area? Is it overlapping this area? Is it overlapping this area? No, it just handles it when any area is overlapped because that signal will be emitted on that case. So let's go ahead and figure out how do we destroy self. That's a lot easier to do. Unfortunately, I don't know if it's unfortunate or not. It's just a matter of like language. Once you learn the term, it's, you know, you don't have to worry about exactly what it means. There's no destroy. There's no self.destroy like you would find in other game engines. Instead, the term we use is queue-free. Queue-free. Whoa! Okay, this is a beginner tutorial. I'm not going to explain entirely what that means. Basically, it means free from memory, as in, that's like the kind way of saying it, you know what I mean? Like how like Saturday morning cartoons will edit it down. It'll be like, we can't say kill. We'll say destroy, or, you know. In this case, we can't even say destroy. We say we're queue-freeing it. Okay, we're basically saying we're going to free it from memory at the end of the process cycle. Okay, that's what queue-free means. If you forget, don't worry, this just means destroy. It's just exactly the same thing. It just means destroy. And if you don't say self, what do you think is going to happen? It's still going to do it because self dot is just inferred. Is just, implied. Very, 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 very cool. Let's test it out. Self.queueFree, if I shoot it, boom! Ship is gone, dead. Ah, yes, I feel so excited because we killed our enemy, right? I'm joking. Anyway, so yeah, we've destroyed the enemy, but it's totally overpowered. Notice how like the laser just keeps going. Like, what is this crazy business? That sounds like a really overpowered upgrade that we don't need to give the player right away. We want the laser to get destroyed too. So this is your practice on your own. I would pause it, but I can't because it's a live stream and I don't want to pause it. So do it on your own. Do exactly the same thing, but make it so that the laser gets destroyed. This is actually, it can be non-trivial depending on how you think about it. Because you might be thinking like, well, I already have it here, right? I already just, like, I'm destroying the ship here. Why don't I just destroy the laser here? I want to show you the safe path. The safe path. Don't do that, okay? Because if you have this touch and handle and modify stuff that's outside of this script, such as the laser, you're going to have spaghetti code in no time. Spaghetti code in no time, because you're going to be like, why is my laser getting destroyed? Oh, it's somewhere in some random script somewhere. Don't do it. Anything that has to do with laser, keep it in laser. Don't do it in the darn enemy. The laser can handle itself. So for the laser, it also is an area, if you remember. So I'm going to select the laser, and under area entered, I'm going to double click on it, and I'm going to connect this laser area 2D's area entered signal, again, to itself, and I'm going to have it create its own function on area entered. All right, very cool. I'm going to go ahead and click connect. Now, it's very easy for you to kind of forget which script you're in because they all look very similar, right? Enemy and laser look like nearly identical. Make sure you're in laser. Okay, very cool. And on area entered, so this should happen whenever it touches another area, and it will touch an enemy. So we're going to have it self.QFree here as well. Not .QRedraw, they added that, I think, in like 4.0. Now I'm like accidentally doing that. All right, self.QFree, both of them have the same thing, and look, they both get destroyed simultaneously. We can keep making lasers, but there's no more enemies to shoot. That's what we need to do next. Okay, I'm going to take a sip. So what are we going to do? We want the enemies to spawn, and the lasers, we already decided that they spawn when the player presses the fire key. We don't want enemies to spawn when the player presses a button. That's weird. We want the enemies to spawn by themselves. So here's the question, and this is a question it's a legitimate question, and the answer is not always obvious. And that is, okay, where are they going to spawn? Right? Under what node? Which code? What code is spawning them? Like, what should we do? Let's take a break. Let's think for a second, and let's start with making these enemies. Let's do what we know how to do. What we know how to do is, whoa, Zozo. What the, how do I? We know about this. Just like lasers. Whenever we want to spawn something, it should be its own scene. Just put that somewhere in your brain, like just moosh it in your brain somewhere. Whenever you need to spawn something, it should be its own scene. Okay, it's in there. Right now, the enemy is not its own scene. It's just a branch of the main scene. So I want to be able to spawn it. Let's make it its own scene. Right-click, save branch as scene. So just the same way that we made the laser its own scene, we're going to make the enemy its own scene. So enemy.tscn, save. So now we have a laser.tscn, we have a main.tscn, we have an enemy.tscn. Again, please don't be afraid of it. Making like however many of these scenes as you want. A lot of, most games, Godot games, have tons of these TSCN files. It's totally fine. In fact, the player should probably be its own scene too, in order to be able to do stuff like respawn the player and have like, other players and all sorts of other stuff like that. Just go ahead and don't do that right now. Just don't worry about that right now. We're just worrying about the enemy for now. To be able to open up the enemy scene, we can click open in editor. Very cool. So now we have our own enemy scene, just like how we have our own laser scene. Well, that's not going to help us with the question we asked earlier, which was, where are we spawning the enemy? Right? Okay, now we have enemy. It's just an instance of the enemy TSCN file. But where are we going to spawn it? We can make the main scene. We could make a script on the main scene. That would work. That could work. We don't want the player to spawn ships, enemy ships. That doesn't make a lot of sense. We certainly don't want lasers to spawn other enemy ships, and we don't want enemies to spawn themselves, because then that would just like exponentially create enemies everywhere. So we could do it in the main scene. We could create a script for the main scene, but you could do that. That's not generally the recommendation, because these levels might have different kinds of enemies. Some levels might have certain enemies and some levels might have other types of enemies. And it can get out of hand when you have it all just baked into the level. And then all the levels have the same script. Maybe they don't, right? So I generally would like to keep it more modular. So what we're going to do, and what's often recommended to do, is to create something that spawns, just a totally separate node that spawns ships, because then we can organize the ships in this one node. We can select all the children of this particular node, so we can get all of the ships of that particular type just by grabbing all the children from the same node. It keeps things organized. It makes it so that only some levels have ships, and also it makes it so you can put the spawner wherever you want if that's how you want to handle it. So I'm going to create actually a new node 2D. It's its own generic node, and I'm going to call it enemy spawner. This thing is what is going to spawn our nodes. Okay, well, now that we have an enemy spawner, we want to be able to spawn them, but like when? Wait, when you press a key? Well, should they spawn every tick? Let's go ahead and create the script for the enemy spawner, because we know that the enemy spawner itself is what's going to spawn them. We're probably going to do it in the code. So I'm going to create a new script. We're going to call it enemyspawner.gd, and we're going to use this as kind of a backdrop for where we're going to do this. Well, do we want to, like, when should they spawn? Should they spawn every tick? No, that would be horrendous. We want them to spawn on an interval, like every second, right? So spawn new enemy, but when? So let's put it over here. Every 1 second, let's spawn new enemy. So we're using the same kind of pseudocode style that we'd used before, but we don't want it to be every tick. How can we make something happen on some kind of interval? We do that with a special node inside of Godot. You just have to know about it, okay? There's no like function called like interval, set interval like JavaScript or something like that. In fact, it's just a node. It's called a timer. So we're going to create a timer node. So I'm going to create the timer node as a child of the enemy spawner node. So timer, there it is, timer. And notice how timer descends from only node. The timer itself doesn't have a position. I accidentally didn't add it as a child to the enemy spawner. So I'm just going to click and drag it to reparent it to make sure it's a child of enemy spawner. It can be a child of main, but I don't want to do that in case, especially if I want to make the enemy spawner its own scene, so it's more modular. But you'll see that the timer, if I look inside of the inspector, it doesn't have any like transform. It doesn't have a rotation or anything. Well, obviously, because like, what's a timer? It's this abstract concept. And so you could have thought, well, why didn't we just make the enemy spawner a child, or why didn't we just make the enemy spawner itself a timer? It just made the enemies as children of the timer. Well, because then they're like not attached to any space, right? They're not in like, their position is referring to a thing that doesn't have a position. So generally, you don't want the timer to have children. You just want it to essentially enhance the thing that it's attached to. It can be anywhere. It just happens to be part of enemy spawner because that's what it has to do with. All right, so now let's change the settings of the timer. What do we want? The wait time, oh, it's already 1 second. We can make it anything we want. We can make it like 1.5 seconds. I'm just gonna keep it at 1 second. One shot is to say like it will, as soon as the time is elapsed, it'll, you know, execute its timer signal once. No, let's keep it unchecked because we want it to happen continuously every time the time runs out. And then auto start is to say, do we want this timer to begin as soon as the timer is born? And yeah, we want it to immediately spawn. Sometimes you don't want to do that, especially if it's like 3, 2, 1, and then it, you know, or if you have some kind of scenario where you don't want it to start spawning immediately or anything like that. But we do want it to start spawning immediately, so I'm going to check auto start. Now, some of you may already guess what I'm going to do with this timer. Just like how the Area 2D has really cool signals associated with it. Oh yeah, the player doesn't have that yet. The enemy, such as on area entered. The timer has one specific legendary amazing signal, and it's called timeout. Timeout is a signal that is emitted when the countdown has completed. Okay, so basically whenever this wait time has finished, every time it finishes, it'll execute that signal. I'm going to come back to the script. And before, what I did was I did this like on area entered, like I let it name the function. You can make your own function name. So I can say func, and I can say spawn enemy or something like that, right? Spawn enemy. So this is our own custom function, right? It doesn't exist. We can call it like spawn enemy ship too, if like you, just to be sure that it's not like some kind of thing that's like, you know, built into Godot. No, this is, you can call it whatever you want. And I'm just showing you how these signals are very flexible. In the node view, I'm going to attach this timeout so that whenever this happens, it's going to call this existing spawn enemy ship function. It's not going to make a new one. So if I double click on it, and not only am I not going to connect it to itself, the timer to itself, I'm going to connect the timer node signal to the enemy spawner, because the enemy spawner is the one that has the script, right? But I don't want to create this new on timer timeout function. I'm going to click this little pick button. Okay, this little pick button over here. And when I click pick, it'll say, okay, well, what function do I want? Did I not save my script? Oh, it's because there's an error. You can't have a function that doesn't have a body. Okay, so I'm going to say print, you know, enemy ship spawn. This function was invalid. It didn't even notice how now it exists. Like before, when I had that error. These are one of those things. Like this is why I love doing this thing like as a live stream. It's still there, but it you know, it's funny. But it wasn't there until I like had done this, and then it appeared. This is why I love doing this live stream, because it's like, that was kind of surprising. I was like, where is the function? In fact, I guess we haven't proven that that was the problem. But now if I come back to the enemy spawner, I click pick, you see there's the function. Because I can do that. I can run into that problem in front of you and fix it in front of you. So you can see that, like, you know, kind of that process, and to know you're not alone. Like when you run into these problems, it's not you. It's like everybody makes these kinds of problems, and I guess I'm here for you. So spawn enemy ship, it's there. It already exists. We don't have to make a new function for this. I'm going to click OK. There it is, spawn enemy ship. Click connect. And now the existing function gets this little green arrow thing. See, the timer is the source. The timeout signal is what is emitting, and the enemy spawner is the target node, and it's calling this function spawn enemy ship. Let's go ahead and hit play. See what's happening. Boop boop bop bop. Whoa! It's, even though the ship was dead, it still is going enemy ship spawn, enemy ship spawn, enemy ship spawn, enemy ship spawn. Very cool. And that's because this is not in the enemy. This is in the enemy spawner. And as you can see, the enemy spawner is just sitting here up here at the top left corner. We're not destroying the enemy timer. The enemy spawner. Cool. Now I want to spawn the enemy ship. And you know what? We know how to do that. In fact, you can kind of give your go at it if you want to hit pause. Yeah, I'm back. Thanks, Sir Lemon. Yeah, so what are we going to do? I'm going to comment this out because we've already confirmed that it works. I know I want to spawn the enemy ship, and we already have made the enemy ship its own separate scene, similar to laser. And in order for us to spawn the laser, we can use that as a reference. We can see that we did this cool like laser scene, you know, export thing so that we could instantiate it. Let's do something similar. So I'm going to go to the enemy spawner, and I'm going to export variable for the enemy ship, and we're going to do enemy tscn. You can call it whatever you want. I like calling it enemy tscn because if you call it something like enemy scene, then is it a packed scene? Is it just like a scene that already exists? And we have to say that it's a packed scene, or else it won't show up properly inside of the inspector. So with this packed scene exported variable, this is what we call a property that's been exposed to the editor. That's the official way we call it. I'm going to, with the enemy spawner selected, hello, save. Why doesn't it appear? Oh, it's because of the error again. I'm guessing that's why. I'm going to save it. There it is. There it is, it appears. It doesn't like when there's an error. It doesn't keep like, it doesn't ignore the errors that are elsewhere in the script. Again, that's why, by the way, we see this word pass. Pass is a placeholder, which says like, okay, just relax, just calm down, okay? Like, we're gonna write something here, just calm down. It's a placeholder, okay? So it worked. There it is. Enemy TSCN. Let's go ahead and like smallify that, and let's find what is it? Enemy.tscn. We're gonna click and drag it over here to the enemy spawners, enemy TSCN little variable we just created. Okay, now that it's loaded in, we can create instances of it. And so again, sometimes you're like you get overloaded. You're like, what do I do? Just start typing stuff. Okay, just type what you know. Just start typing in enemy TSCN. You know it has to do with that. And as soon as you type that, it helps you remember. It's like, okay, now we have enemy TSCN. Like, what do we do? I remember you have to like create a variable or something like that. And it really does help you to kind of jog you along. It's like, okay, well, I remember I created a variable and we're making a new enemy, and but we're not setting the new enemy to the scene. That doesn't make any sense. Oh, we're making a copy of the scene. Is it like .copy? Is it .clone? It's .instantiate. Okay, very cool. It's all right. It really helps to like decompress when you just start typing. Just start typing stuff that you know you already are going to start typing. It doesn't have to be perfect. I mean, it does, but it'll it'll become perfect as you write. It's okay. Very cool. And then what do we need to do with this new enemy? Well, oh man, we have to like, there's some kind of add child thing, but I don't know where I should add it. Just again, relax, just start typing stuff. Add child. Okay, we know we're gonna have to do something like add child. All right, okay, now that I've written add child, I feel better already. I feel like, okay, cool, we're adding a child, we're give birth to it. Who's giving birth to it? Okay, are we gonna add it as a sibling or as a child? Well, in this case, it doesn't really matter. We can put it in the enemy spawner. We're not going to destroy the enemy spawner. And the enemy spawner is not going to move, so it's not going to like mess up the position of our ships. So we can just add it right here. Add it to the enemy spawner, and then whenever we want to access all the children of the enemy spawner, we can do it. All of the enemies that are inside of the enemy spawner. So why not? So self.addChild, and we're going to add the new enemy. Very cool. Well, where is this enemy going to be? Just like we had done before, we're going to create a new enemy position. We're going to change the position of the new enemy. Where? Well, with the laser, we wanted it to spawn at the player's position. Well, where do we want to spawn this enemy? Right at the spawn position? Like the enemy spawner position? We could do that, but then it's just going to spawn in the same place every time. And that maybe works for some games, but for this, we want them to kind of spawn at a random location at the top of the screen, right? There might be other ways that you want them to spawn. It really depends on the design of your game, but for this game, let's say we want it to spawn at some random like horizontal position at the top of the screen. Okay, so that's what we're going to do. So .y, we want it to be somewhere at the top of the screen, like, I don't know, -50, which is a magic number. You know what? It's a magic number. Well, we can fix it later, maybe. Or we can just set it to the enemy spawner's Y position so we can move the enemy spawner at least vertically. And where are we going to set the enemy's X position? I don't know, let's just go 300 just to see if it works. Ta-da! Do-do-do-do-do. Hey, look! There they come! Look, suddenly it's like a game where it's like a road, you know? It's like the right side of the road and the left side of the road. They're spawning in the same place every time, which is kind of boring. We want it to spawn in a different location randomly, okay? So how are we going to do that? We're going to have to develop random numbers, and that's why I added that as part of this tutorial, because random numbers are really the, like, where games are exciting, where the unexpected occurs. So that's what we're going to do. We're going to create a new variable, and we don't have to make a new variable, but I want to create a new variable, and I'm just going to call it randx. And we want it to be some random number, right? How do we create a random number? Well, first let's think about it. What's the range of the numbers we want to create? We want this ship to be anywhere from, let's open the transform so we can see it, anywhere from 0, right, to all the way over here at the right-hand side, which is 535. Okay, we could type that in manually. Like we could say between 0 and 535, but what if we change the resolutions later on? What if we give the player the choice to change the resolution? That magic number is not going to help me. But first, let's just, it's quite simple, it's quite straightforward to create a random number. We just do rand, and then we either do rand f range or rand I range. Okay, so if we do rand and then range, this is kind of fuzzy search, so it finds both the rand f range and the rand I range. And the difference between the two is very simple. One is rand integer, so it's whole numbers, and one's rand float, so it's floating point numbers. We don't want it to be fixed to integers, so let's just do rand f range. And so when we do rand f range, we can say from 0 to what, 540 or some magical number like that. And the x position of the new enemy, instead of typing it as 300, let's just go with whatever the rand f range function gives back to this rand x variable that we're storing. So rand x. When we save, I just want to confirm that it works, so that if it works for you, great. If it doesn't, you can kind of work on it while I talk more about it. Notice how it comes in at a random position every time that timer elapses, that timer's timeout is emitted, and the enemy is spawned. This is the first time you've seen a function that has 2 arguments, I think. Maybe, maybe not. Yeah, so a function can have however many arguments that it's expecting. The rand f range function, and it'll kind of help you. Like if you do rand f range, you'll see that it tells you from, which is a float, to, which is a float, right? A number to a number. And if you control click on it, it'll even tell you. It returns a random floating point number. It gives you some examples from this number to that number. It's actually very, very nice, very straightforward. It should hopefully not be too hard to understand that. And we're storing that inside of this variable. Now you could have just done this directly. You know, that would have worked totally fine. Totally, totally fine. I'm just trying to get you in the habit of doing this, because you might be using this rand x somewhere else a little bit down this, you know, inside of the code. Having it as a separate variable just makes it cleaner, easier to see what you're doing. It's more descriptive. You don't even have to write comments because it's very obvious what you're trying to do. Very, very cool. So that's how we do that. It works perfectly fine. Perfectly fine. Maybe in the kind of like questions and answers, I'll show you how to like make a new vector, but you didn't even need to like make a new vector where it's like, you know, x comma y, because you can just change the existing x and y separately, just like this. In fact, I'm just going to go ahead and put this down here so that they're next to each other. This -50 is also a magic number, so you can fix that on your own time. I'm just going to leave it there just to show you that I flaunt the conventions. I'll allow magic numbers every now. No, actually, I don't like this magic number. This magic number is actually bad. This one's a bad one. To fix this magic number, 540, let's go ahead and figure out what is this 540? What does it refer to? It refers to the width of the viewport, right? When we did this whole like project settings under general, it was the viewport width. Well, how do I get the viewport width in the code? You can get the viewport width in the code by typing in get viewport rectangle. Unfortunately, there's no get viewport width. That's not an option. Unfortunately, it's just not. You have to get the rectangle of the viewport. And when you do get viewport rectangle, you can do like, okay, .x, right? .expand. Oh, it's like it's mocking me. No, rectangles don't have x properties, unfortunately. But the size of the rectangle does. So let's do get viewport rect, and then let's do size. How about that? Now it's happy, but we're going to get the x component of the size. Wow. I'm not kidding. That's what it is. That's what it is, folks. That's what it is. I didn't make the rules. Just follow the rules. What we are doing here is what's called chaining. When you have like a, you know, sequential back-to-back like dot operators, this is what's called chaining, and it looks awful in my opinion. It's so just do your best to make it like clear to you what this is by coming up with variable names that are relatively clear. So you can call it something like viewport width or something like that. That's pretty good. And I'll change this to viewport width. All right, so to get the viewport width, we do this get viewport rect thing, which you can get at any time because this belongs to this node 2D canvas item thing. And we use this .size.x. Again, I didn't make the rules. That's just how you do it. All right, I'm going to hit play, and hopefully it still works. It does still work. We're in a good time. Yeah! Every time's a good time when we're blowing up enemy ships. All right, so I'm gonna delete this enemy that's already on the window because it's just, we don't need it anymore, right? Do. Boom. All right, cool. It works. Now that we can spawn enemies and we can destroy enemies, what are we gonna do? Well, we already destroyed them. We destroyed them and then spawned them. I said it in the backwards order. We're getting close to the end here. Right now, our game is a game, but right now it's more of like an interactive screensaver, right? There's not like, we don't have any means of like knowing that we did a good job, right? We want to know how many we killed. We're basically like the intergalactic Red Baron right now. We got to know our kill count, right? So let's add score. And the reason we're adding score, again, because I want this tutorial to be as concise as possible to give you all of the most important things that you're going to probably have to deal with. And score is going to illustrate one of the most important topics that you're going to have to learn and segue over to more advanced tutorials, which is how can we keep track of a score variable that other parts of our code want to know about, right? We're going to have a way to show the score, and the enemy is going to have a way to report the score. But the place that we show the score and the place that the enemy's, script are not in the same place, and they shouldn't be. So how do they share that data? And that's where this tutorial, I'm not going to be teaching you like the super awesome, most best practice. I'm just teaching it to you in a way that you should be thinking. So I'm teaching you in kind of a way that some people would be like, oh no, but really it is how you need to think about it. All right, so this is what we're going to do next. All right, first of all, let's figure out when are we going to increase the score? Before we even create score, before we even create any way to show the score, when are we going to increase the score? We're not going to increase the score when we spawn an enemy ship. We're going to increase the score when we destroy an enemy ship. Yeah. So we're going to come back to enemy.gd. And when do we destroy the enemy ship? We destroy it right here. So this is when we're effectively going to increase the score. This is where, at this point, is where we need to report to the game, hey, enemy died. Enemy died. Do something about it. Enemy died. Increase the score. Yeah, skepsis. All right, you got it. So we're going to increase the score. Now that we know where we're going to increase the score, now we have to figure out, well, where is that variable? Do we put the variable here? Do we say like var score equals here? Well, no, because if the enemy dies, then the score dies too. It's like, that's not good. Each enemy has its own score. What? We can put it in the player, but if the player dies, then the score dies too. It's like, no, we want the player to be able to respond without losing all the score. Remember, when you destroy an object, all of its member variable values are dead too, right? And when it respawns, it goes back to the defaults. So yeah, are we gonna put in a laser? No. We're gonna put it in the main scene? You could. But the problem with putting it in the main scene is how are you gonna then access the main scene? What if there's like gonna have multiple scenes? What if the main scene just refers to like a level? What if this becomes like level 1, level 2? They're always gonna be in that? The structure of the scene might change a little bit. And so it can get kind of annoying. And is it really a property of the level that you have a score? That's more like the property of like something that's beyond the level, right? Something that you want to save between levels, like a high score. Maybe, you have some other kind of fancy system. Don't try to lock it down to the concept of a level. So that's where we're going to have to think a little bit. And what we're going to do is we're going to create a global variable. Okay, a global variable. That is a variable that all of the code can access at any time. Okay, so that sounds really bad, like at first glance, because maybe even your high school programming class, they're like, global variables are made of evil, straight evil, or something like that. No, not really, actually. Especially if you're a designer and you're making a game for like a game jam or something like that, it's actually not that hard to refactor global variables to something that is more what you want it to be. I'm going to be the first to tell you that global variables in this case are actually a better place to start than just putting score in some random junk, okay? And like trying to go through some complicated like node. Notice how I have not taught you about like get node and stuff like that. Because as much as you want to avoid like having a strict idea of exactly how these node structures work. You want to be able to change the node structure. In fact, the designer might screw up your node structure as it is. They might screw it up and the game breaks suddenly. You don't want the game to break just because like your designer was like, whoops, and now the player's part of the space background. Don't depend on those the exact tree structure because it can change and you want it to be flexible to change. So having a global variable and having your nodes just access the global variable regardless of the hierarchy of nodes is actually a good starting point, okay? And that's what we're going to do. So how can we do that? How can we create a global variable? Kind of like how the input method, like the input class is just you can use it wherever you want. How can we do that? How can we create a class, basically like an object, like the input object, that you can just use wherever you want? This is where we have to understand a little bit more about the scene tree. If we look here, notice how the local tree has this like main, space background, player, you know, blah, 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 whatever. And when I click remote, you'll see, wait a minute, main is not the root. The root is the root. What the heck? The main is just what we call the current scene. It's basically the root of what we consider to be like the main scene. But there's a root above it, because if you remove the root, which is okay, if you remove the main scene, that's okay, you can make another main scene. But the root doesn't get destroyed. The root is there all the time. There, you can make a scene that is a sibling of the current scene. That's what we're going to do. We're going to make another scene that's like totally off in its own world, that's not part of the viewport at all, is just totally off as a sibling. It's kind of like Crazy Uncle Jack or something like that. And anyone can talk to Crazy Uncle Jack, and sometimes Crazy Uncle Jack tells you some crazy things, but it's just Crazy Uncle Jack, so it's fine. And we're basically going to make our Crazy Uncle Jack as like a sibling of main. It's going to also descend from root, but it's not going to have anything to do with the current scene. It's just something you can access at any time. And to do this is what we call what's called an autoload script. Let's do that. So if I click project settings, so just like how we could find the input map, there's another place you're going to go a lot. It's called the autoload tab. The input map, autoload tab. The autoload tab is your magical nodes, your magical nodes, the global nodes, the nodes that exist everywhere. And the word that we use to describe these nodes is what we call a singleton. In fact, I'm going to write that down so that you can darn have it in your mind and you can learn more about it. Singleton. That's your global node. It's a singleton node. Very cool. And don't listen to all the haters. You're in a place where it's totally fine to use these. And what are we going to call the node? Let's call it game state. Okay, this is going to describe the state of our game at any time, regardless of what current scene it is, regardless of like what if our player is alive or dead. Game state, and then let's go ahead and click add. And then it's going to be like, wait a minute, if you're going to make this game state node and there's not already a path, see, like we could have already created the script and we could have said like, here's the script, and then like just select one. Well, we don't already have a game state script, so let's click add. And this is where Godot is being like inconsistent. Before, like we were using this Pascal case with like capital enemy.gd, capital laser.gd, but now it's like lowercase suddenly. I'm again gonna go with the defaults because that's what Godot is telling me to do, even though it's inconsistent. We'll talk about that later. It doesn't matter what you call the script, okay? Haters are gonna hate. So the node is called game state. We can access it from anywhere in any script anytime we want. And it's going to, the code for this game state is located in this new gamestate.gd script that's right here. I'm going to double click on it because it didn't automatically open it. I double click gamestate.gd just like everything else. It gives us like process and ready, and both of those work just fine. We don't need them right now though. And it extends node, not even node 2D. It extends like the most basic type of node, which is called node. It doesn't have a position or anything. That's fine. But what I want to point out is that in this enemy thing, we can now say game. Oh, look at that. We could have called it whatever we wanted. It's not like a built-in thing. We just called it game state. If you remember, inside of the project settings, we called it game state. There it is, game state. Just like the input class, we can just use it wherever the heck we want. So inside of game state, what I can do is I can go here to here, and let's create a variable, and let's just call it score. Why not? And let's start it out at 0. Let's go. I missed you too, Mr. Dude. All right. Game state, score. So now when we come back to the enemy script, it's like, was it really that easy? Game state dot score. Oh my gosh, it was that easy, wasn't it? This is how powerful singletons are, and this is how powerful these global variables are. At this point, you as a beginner, you as a designer, you're like, the lightning is coming from my fingertips. I can do anything now. And good. I'm glad that you feel that power. And I want you to use singletons as much as you want and as long as you want until you realize there's probably a better way to do this, isn't there? And then you can come back to me and then you can watch the advanced tutorials. But that's fine. It's you know what? No problem. You should definitely use Autoload scripts. Even the best, like most like amazing programmers use singletons. They just, you know, are kind of careful about it because there's some things that you can do here that aren't so careful. So what I'm going to do is I'm going to say gamestate.score plus equals, I don't know, 10. Can't be 1. Got to have something more exciting than 1. So yeah, we're going to increase the score by 10. And so now when I go ahead and run the game, remember, just to be clear, we're in the enemy. Whenever it touches something, we're going to destroy the enemy, and then we're going to increase the score by 10, the game state score that we can find just floating around here in this global variable. All right, let's go ahead and play. And in order for us to see the change, I'm going to go to the remote tab. So I'm going to click remote so that we can see it. And notice we see 2 things here. We see that not only do we have the main scene here, but the main scene is no longer the only scene that descends from root. And by descends, I mean as like a direct descendant, as a direct child of root. We now have that crazy uncle game state. Crazy uncle game state. When I click on game state, you can see that score is a member of that game state. It's currently 0. But if I come back to my little game and I destroy stuff, notice how it says 30, 40, 50, 60. See how it's increasing? So we have demonstrated that the game state score variable is changing in this totally separate script. Totally separate script. And that's amazing. But this is extremely dangerous because you could have accidentally said game state equals 10. What if you have like, you're messing with score in like 10 different scripts and you accidentally said game state score equals 10? What? You see how that's a problem? Because you accidentally set the score to 10 and now it's like, when did that happen? Like, those are the types of bugs that just wreck everything and are extremely hard to trace because there's no error. It worked just fine, but it broke everything. Singletons can break everything pretty easily. So instead of just allowing me to say game state like plus equals 10, score plus equals 10, we can at least like make it like slightly safer, by instead of saying score equals 10, let's just create a new function. We don't actually have to do that. Dang it. I'm going to save it for the end in case there's time. Yeah, I'll let you do it if there's time. Again, I'm like, my like code smells thing is like triggering. Let's just let you be bad. And also, you know what? You've learned enough. You can fix this magic number on your own. Each enemy that you create can maybe have like a separate, like what its life is worth or some morbid thing like that. Like, you know, life points or some junk. I'll let you think about that and you can change it because you're smart. And, you know, you know what a magic number is and how to fix it. So we're just going to go with this. But we're not going to say equals 10. We're going to say plus equals 10 because let's fix that. Okay, now that we've done that, we have to have some way to show the player the score, not like us like behind the scene having a secret conversation with Uncle Game State. We're going to have the score show up. Well, how do we make something show up? Well, there's a node for it. Let's go ahead and make it. And let's make the node visible on the scene. And it makes sense for it to just be a child of main. Let's go ahead and click plus. And this is where I recommend going and watching some like video on creating interfaces. See, we have node 2Ds and we have controls. Controls are how you create user interfaces like menu systems and like, you know, GUIs and stuff. You watch something else, okay? You can figure it out. So I'm just going to use the most basic kind of text object that we can use, a control, and it's called a frickin' label of all things. Okay, if you type text, it's going to be like text edit. No, we're not trying to edit text, and you get confused instantly. You're like, which one is it? It's called a label. It's called a label. Do label. It's a simple thing. Click create. There's our label. Very good. And in the text field, it's currently blank. I'm going to make it say score : 0. I zoomed in real good to show you how tiny it is. We want to make it bigger. To make it bigger, this is, again, the Godot way of doing it is not very obvious. But once you've figured out how to do it, it's not the end of the world. There's no freaking font size. There's like a cajillion properties, but not font size. So what you have to do is you have to create a new label setting because you can have label settings files and stuff, right? If you want to be able to adjust things or have, you know, powerful defaults that you can apply to different labels. Godot is really smart, but again, little bit of a learning curve. That's all right. It's very quick and simple once you get it down. Under label settings, just click on where it says empty and do new label settings. So that'll just create like a new label settings object. We're not importing one. We're just gonna do a new one. And it's like, oh, cool. Now we have our label settings, but now what? This is one of the times, now you'll see this in a variety of other places in the engine, but I'm only doing it here so that you learn how to do it and you can then apply it elsewhere in the engine when you watch other tutorials. You just simply click on it. It's so weird. You click on it and now there's the settings. Ta-da! You click on the new label settings and now you go here to font and finally you can change the font size. Let's do 36. I don't care. Just change it. You know, make it whatever you want. If you change the size of the label, it doesn't change the size of the text. Okay, so you have to change it here with like size. And don't try to change scale. Scale is just gonna make it blurry and silly. Just right here, the size of the font. Very good. And now when I hit save and I hit play, just see what it looks like. Doesn't look great, but that's fine. We can now adjust it. We can now like move it here. And again, watch a different video on user interface so you can learn about how to like make this scale well for different resolutions and all that kind of fun stuff. I just want you to become quick and dirty and dangerous as fast as possible. So this is good enough. Ta-da! It says score 0. That's all I really needed it to do. And is it gonna work? What do you guys think? Dun 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 dun. Shoot, 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 boom, boom. What? No score. Why not? I'm so mad. I'm gonna kill them all. They're cheating me. The Red Baron of outer space is mad. Yeah. If you really want, you can like confirm like that Uncle Game State is keeping track of the score properly. I mean, see, Uncle Game State. Hello. 20. Yep, still works. Score. Nope, doesn't work. It doesn't work because what? The label doesn't know what the score is. We just typed in score : 0. So what we need to do is we need to make it so that the score knows. In fact, I'm not going to call it label. I'm going to call it score label because there might be other labels. I just changed the name of that node. I want to change this score label depending on the score. And so here's the problem. This is where you can really get yourself in trouble. It's like, okay, well, when does the score label change? When an enemy is destroyed, right? So it's like here, right? GameState.score, and then like the score label dot, you know, change text or some junk like that, right? Don't do it. Don't do it. Don't do it. You might know, like, oh, well, the score label is a child of main, and these enemies are children of enemy spawner, so I can just kind of like do one of these numbers. It's like, well, I didn't teach you about that, but let's do get node. And you can do like, look, it's like, you know, dot, dot, it's like backwards a little bit, and then we go back to the main scene, and now it's like down here, and it's the score label. Don't actually have to go back even more. Don't do this. Don't do it. Ever. And you might be like, oh, well, what I could do is I can like, export a node, right? Can't you export a node? Okay, I'm getting out of hand, but you can. And you can then drag score label into there, and then you can change score label there. Don't do it. Enemies don't need to be able to touch a score label. That's not something that is meaningful to an enemy. Don't do it. Don't make scripts touch nodes that don't directly have to do with what they're concerned with. This already was dangerous enough, okay? This should be done differently already, but there's not an easy way to do it for an absolute beginner. That's what this tutorial is about. This should just say, I died, and then whoever hears it should change their stuff. This is fine enough. But for score label, we're gonna do the same thing. The score label is gonna have its own script. So I'm going to make a new script for score label, scorelabel.gd. I'm going to click create, and okay, I just want to delete everything. I don't like looking at stuff like that. When does the score change? Well, the score changes when, this is where it's easy for you to be like, see, that's why we need to know about the enemy. That's why the enemy needs to know about the score label. It doesn't. When does it change? Well, when the enemy gets destroyed. But guess what? The score label doesn't need to know when that happens. It can just constantly just update its text to whatever the current score is. So that's what we're going to do. Every single tick, so func process, every tick, we're just going to change the score label. Dot text, if you remember, it's, what's the property called? It's called text. See, if I hover over it, its property is called text. Equals, and let's just confirm that it works. Let's just say 10 or some junk just to make sure that it works. And then I hit play. It's mad at me. Oh, yeah. Oh, why am I so dumb sometimes? Self.text. It's like, what score label? Thank you, sorry. Just like self.position, self.text. It's its own text property. It's not like, it doesn't talk in the third person. There you go, 10. It's not like Shaban says this is how you do it. All right, yeah, so self.text equals 10. And it worked, right? So it says 10 up here at the top. Cool, we don't want it to say 10. We want it to say whatever the score is. How do we get what the score is? Well, we know how to do that, right? We talked to Uncle GameState. GameState.score. Text equals GameState.score, right? If we hit play, we have a problem. It crashes. It gets mad. Is it because of the game state? No, read the darn error message. Invalid set index text with value of type int. That's not 100% clear, I think, to you. So I apologize if this error, and that's why I'm here. Here's the thing about Godot, unlike some programming languages. In Godot, it is strongly typed. Do you understand what strongly typed means? Let's go ahead and kill this for a second. Strongly typed means you can't change the type after it's been set. So if I were to say var, I don't care, my integer or some junk like that, let's even say integer just because, you know, and it's a 10, right? We can change it. We can say my integer is equal to hello, and is it going to get mad? It doesn't get mad. The reason it doesn't get mad is because we didn't specify the type. If we said explicitly, no, it's an integer, then it's going to be like, whoa, you can't do that. That's wrong. It's evil. You can't do it. You can't change this because it's all we've explicitly said it's an integer. So you can't change its type. So if you don't specify what the type is, it's now a variant. It can be anything. It's a variable. It can change its value and it can change its type whenever it wants, willy-nilly. Okay, well, it's like, well, we didn't do that for game state. Like, we didn't say that this is a number. Well, here's the problem. This is what's mad, self.text. And if you look at self.text, text is a, well, it doesn't say it's a property, but it's a string. It is a string. It can't change. So when it says GameState.score and score happens to be an integer at the time, it's going to get mad. So you can't do it. So this, I'm going to comment this junk out. You can actually select stuff and do Control-K or Command-K on a Mac so that it like comments it out just so that it's still there and you can see it. Let's go ahead and change this. So we need to convert score into a string. To do that, just about every programming language that you're probably going to write in, most of you, will have a way to convert something into a string. And in GDScript, it's called str. str is a function that takes whatever is between the parentheses and it's going to attempt to convert it to a string. So now when we do self.text equals attempt to convert this into a string and I hit play, then ta-da, it works. So now when I shoot stuff, ta-da, it says 10, it says 20, it says 30, it says 40. That's amazing. So we needed to convert it into a string. Not all things can be converted into a string, like a packed scene. I don't think you can convert that. Maybe you can, I don't know. I haven't tried it. It's kind of a weird thing to try to convert to a string. But here's the problem. We wanted it to say score colon, right? So we can do that by typing in score colon and space, and then it's like, well, what? You can't do that. Well, you use an operator between them. We use the plus sign. So we can use the plus sign to add two numbers. And we can use the plus sign to combine two strings. This is what we call an overloaded operator. It's both the string concatenation operator and the addition operator. So we use that to combine a string, a message, with another string, which has been converted to a string in this case, GameState.score. So now it says score colon 0, score colon 10, score colon 20, and so on. That was cool. All right. And we were able to do it because the score variable has been shared between the enemy and the score label, but we didn't directly share it. We didn't like have them communicate directly. We had them communicate to a common value. That's what you do. And that's how you're going to learn think in that way so that it's easier for you to adjust to even better ways of handling this. You don't make nodes communicate with each other directly. You don't do that. You make them communicate with a common parent or a common, in this case, variable that we have as a singleton. That's how you have them communicate. All right, very cool. Because now you can delete score, you can delete enemy, you can delete whatever the heck you want, and it's not going to break your game. The score system won't break if we remove the score label. It would have broken if in the enemy we were like, get the score label. Oh, it's not there anymore, broke. No. We can remove whatever the heck we want, and it'll still work. All right, very good. Now that we have a score, let's do our last kind of thing. Let's make it so we can lose. Currently, we can't lose, right? When the enemy comes down and we resist the temptation to kill the enemy instantly, we notice it doesn't. It just passes right through the enemy. And why is that? Well, the enemy currently has no, it's like all offense. It's like a Twitter account, right? It's like this anonymous thing that just attacks. That's all it does. It's its whole life is to attack. No, we have to allow it to lose sometimes. It has to die. The player has to lose. Otherwise, this game's just not that exciting or fun. Let's go ahead and do exactly that. We're going to convert the player into an area 2D, so nothing really big and fancy and different, but we will have to deal with a problem. Now that the player is an area 2D, the covert area 2D whose icon hasn't been changed. Come on, Godot. Let's go ahead and create our collision shape, and ba-dum-bum-bum-ba-doom. Don't save the branch as a scene. Let's add child. It's going to be a collision shape. The collision shape needs to itself have a shape property assigned. Let's look carefully at this and think what's the most close, what simple shape is most closely looks like this? Yeah, a circle. So let's go ahead and change it to a circle. And we can make the enemy circle smaller because you know what? Like we want players to think they're like better than they are. So it's like, oh yeah, I barely missed. Phew, that was good. No, we just made the collision shape really small. So now it's like we can like, you know, dodge bullets better or dodge, you know, enemy ships and stuff. Very cool. But before you do anything, this is where you can get overzealous. You can get overconfident. This is where you can maybe accidentally like just keep writing because like I've already done this, so let's keep writing stuff. No, test it here because we already have a problem. If I shoot, what happens? Whoa, do you see what's happening right now? Do you see what's happening right now? And if I shoot, okay, the enemies die. That's kind of cool. Player doesn't die, which is cool because we didn't do Q free on the players. That makes sense. But notice how the darn projectiles don't shoot anymore. They're just like stopping right there at the player. Why is that happening? What the heck? What the heck? I guess pause the video and think about it for a second if you want to, if you're not watching the live stream, because I'm going to tell you the answer. The answer is look carefully at the darn laser script. The laser script says on area entered self Q free. Look at how we carelessly rewrote this script. It's like, yeah, it touches anything, it destroys the laser. What if it touches, you know, like a power up? Should it destroy the laser? Maybe it should go through the power up, right? What if it hits like a friendly ship? Does it destroy the laser? Maybe it should shoot through the laser. You know what I mean? Like, come on, don't just destroy the laser all the time, anytime, any day. We want it to be destroyed selectively. Right now, on area entered is going to be emitted whenever it touches any area. And in this case, it touches the player area. The player has an area too. So like it's going to destroy the darn projectile. So here's where you can easily write hacky code. Hacky code that is in like, well, I fixed it. Like you can do something really hacky, like, well, if I put the collision shape like down here, or maybe we should make it so that when we spawn the enemy, it doesn't, or the projectile, it doesn't spawn it at the player, but it spawns it like slightly above the player. You're gonna run into trouble, okay? You're gonna run into trouble. Like it's the exact location of the projectile is gonna change. You change the like side of the projectile slightly, it's gonna like break your game. Don't do that. Let's write it in the code. Basically what we wanna say is if, not just when we destroy, like when, there are a lot of ways we can do this. So save this for the end of the Q&A, those little advanced insights. There are many ways to handle this. I think this is one of the more descriptive ways to do it. Basically what I want to do is we want to Q free on the projectile, but only if it hit an enemy. That's when we should queue free. How does it know that it hit an enemy and not a player? There are so many ways to do this. Goldarn ways to do this. So how do we do it? I kind of really brainstormed what's the easiest way for a beginner and what is the way that is going to get you in the least amount of trouble in the future. I think the easiest way to tell you right now, and I'll talk about it later probably, hopefully if there's time, is to use what are called groups. Okay, so in the enemy scene, because that's where it is now, notice how we have the enemy. It has a signal attached to the script, as you can see, this little Wi-Fi looking thing. If we come over here to the, remember how in the node tab is where we found our signals? It's kind of like, I just thought like, you know, they probably just like put things willy-nilly. It's like, really, signals and groups, like how they're not really related. But anyway, that's where they are. So there's the inspector tab, there's the node tab where we have signals, and then there's this like secret secondary part of the nodes tab called groups, and that's what we're going to do. Basically, we're creating what's called like a tag. Tags is a term that's used in other game engines sometimes, and it's easy to kind of get carried away with them. I don't want you to rely on them too heavily because they shouldn't be used for necessarily everything, but this is a good use of them. So under groups, what I can do is I can create a new group called enemy. So when I do enemy, I can click add. And now that I have this enemy group, cool, it's right there. And I can make as many groups as I want. Very, very cool. If I click manage groups, you can see all the groups that exist inside of my game engine, right? It's inside the project right now, so you can have a variety of different groups, and you can like add different things in different groups, which is really cool, especially because, you know, you can globally change groups, you know, whenever you want. And groups are a great feature, especially if there are going to be different kinds of enemies, right? No matter the kind of enemy, you want the laser to destroy itself when it collides with the enemy. That's the most important thing to consider when you're using this type of feature for this purpose. You want the projectile to always destroy itself whenever it hits anything that would be called an enemy, whether it's a boss, whether it's like this kind of enemy, a squirrely enemy, like whatever enemy, they should always be part of this group, and that allows you to categorize things in the code whenever something has to do with enemies. So that's what we're going to do. So now that we've said that the enemy is part of this group called enemy, we can ask to see if the enemy is in the group. Here's the problem though. How do we know what hit the projectile, right? We're in the laser.gd and we're saying self.queueFree, so we know who we are. We know who the laser is, like self, right? But who's like, how do we know that the thing we collided with was a player or a projectile or an enemy? Like, how do we know? That's a part that I didn't mention before because it wasn't really relevant at the time. If I hover, like if I see where it says area entered, notice how the signal, it says area entered, but there's something between the parentheses. In the parentheses, it says area, and it's a type called area 2D. It's emitted when the received area, notice how area is like kind of, I guess you can't see it because it's probably like off the screen. It says like, there it is, received area is kind of in blue, which is referring to the thing that is being sent into the function, okay? Some signals, such as the timeout, where the heck is that? The timeout signal doesn't have any parameter, is what we call it. It's like extra information associated with this situation that occurred. What's useful extra information about whenever an area collides with another area? Well, the thing that it collided with, right? And so that's what this is. Similar to how process has this delta thing that gives us special additional information about process that's relevant, our area signal has, area entered signal gives us who it touched, which is amazing. Here's the problem though. Well, is that it's calling it area. It's like, well, what area? Area is in like this area, that area. I don't think this is a very well-named variable. I think it should be called other area. And guess what? You can call it whatever you want. You can change its name. Doesn't make a difference, which is all very cool. So I'm going to say other area so that you know that this is referring to the other area. Self refers to, in this case, the area that we're colliding, the colliding area, I guess, that's attached to this. And then the other area is the one that it's touching. Okie dokie. So if it hit an enemy, so how do we do that? Well, we use an if. And then we're going to use a special function. In fact, I'm going to just write it here so we can start to see it. It's is in group. You see that? It like writes it for me, and then it's asking, it's a string, what is the name of the group? This is kind of this is, I think, would be an amazing feature. I'm not sure why they haven't added it yet into Godot, because if you do like input.is action just pressed, it like gives us a list of all the darn actions, which is cool. Groups are also globals, I think. So not sure why it doesn't find it. Someone might have to tell me. Is in group, it doesn't tell me all the groups. Like you have to just remember what it's called, and you have to not spell it wrong. Okay, it has to be spelled exactly like that. The other problem is you could easily misspell it. And what if like someone changed the name? Like, right, you know, if I were to come over here and I called, I don't want to get too much into that. We'll save that for the end. This is, so it's not perfect, but it's better than I think other things. The other problem is when we say other area dot is in group. Very cool. We have to do it to the other area. Is in group. If we had done it just by itself, it was implying self.is in group. Okay. Very good. So other area.is in group. That's what we're asking. This is a question, just like is like was, you know, action just pressed. This is a question. But notice I can't control click on it. I can't control click on it because it doesn't know what other area is. That's what's kind of annoying in my opinion. See, if I do other area dot like it knows speed. That's kind of cool. For some reason, why would it know that? It currently, like, you know, it doesn't know unless we say that it's an area 2D. Okay, so, oh well. Let's go ahead and say if other area is in group, because that's where we're going to have to go. Then we'll self.key free. Now when we hit play, we can shoot. And notice how they don't die, the projectiles don't die, but if they hit an enemy, they die. Hopefully this makes sense. Okay? They die when they hit the enemy. They don't, the projectiles do not die. The lasers don't die when they touch the player scene, the player area. Because the player area is not in group enemy. Very good. Hopefully that all made sense. I think that's the most straightforward way to do it. Now, that's currently the player doesn't die still. Like, I'll let you think while I'm doing this. The player currently doesn't die. Notice how it just goes, it says killing enemies by crashing through them. Upgraded hull, here we go. Yeah, this is a cheat. We want the player to die, and so we'll just do the same thing we did for these other things. Let's attach a doobity-doop-bop-bop, a signal for player. Oh, that's probably really loud, sorry. Area entered, and we're going to attach it to the player, and we're going to call it on area entered, and we'll do exactly the same thing we did for the other things. We're going to do self.queueFree. Is this going to be good? What do you think? You can pause it and guess what you think will happen. When I shoot, oh, I kill the player. Kill the player instantly as soon as I shoot. Well, same problem with the laser, right? You kind of refrain from the temptation to copy and paste. Just get some practice typing this stuff. So if, and then area.is in group, doesn't help me write enemy, and there we go. Now, you can change the name to other area, but be careful when you do that. Okay, be careful because, okay, see, the projectile does not kill itself, or does not kill the enemy. The player doesn't. We're not killing ourselves instantly, but we do still die when we crash into an enemy. If you're going to change the name here, notice how you could very easily break your code because this is no longer other area. Okay, in fact, it's going to yell at me because it's like, what the heck is area? So that helps a little bit, but unfortunately, as far as I know, and correct me if I'm wrong, but I don't think Godot has a way to just like rename, right? Some editors allow you to like rename something and it'll like rename all instances of that variable, which is freaking cool, but I don't think Godot has that feature. So anyways, like it'll traverse and like change just that. It's not even, it's like stronger than Control F. All right, so what are we going to do? We want a game over. So let's do this fast because you know what? We're like, man, we've been going on a long time. So let's do something real lame. Let's just make it say game over. All right, so I'm going to make a new label, attach it to main, just like score text. Create a new label. I'm going to call it game over label. Go ahead and do that. I'm going to make the text say, believe it or not, I'm going to make it say game over. Ta-da! Way too small. We really have to alarm the player that they lost. Open the replace menu. Yes, but the replace menu, as far as I know, is not smart. It'll change the word everywhere in the script, even if it's not like local to that specific function. Potentially. I mean, anyways, maybe you're right. Maybe it is smart, and I haven't checked it. We'll look at it later. So let's do new label settings. Ta-da! Let's change font size to 52. That looks big. Whatever. And it's not centered. So what we can do is we can make this box the same size of the viewport. And let's just center align it, I guess. Let's see if we can do that. Horizontal alignment, let's do center. Vertical alignment, let's do center. There we go. There we go. Game over. So now when we hit play, it doesn't look good where it's going to be. Yeah, it looks pretty good. That's fine. You can move it up a little bit if it kind of doesn't look centered, even though it technically is. And I don't want it to appear all the time, right? I want it to be invisible by default. So now it's invisible. You can also lock the node too, so that you don't accidentally move it if you want. Game over label is now invisible. So when should it become visible? That's where we're back to the same thing, the same topic of score. Exactly the same topic of score, so I don't want to dwell on it too much. It's the same idea where, okay, the enemy died, so we should change score. Should the enemy be able to talk to score? No. Okay, the player died. The game over label should now be visible. Should the player be able to talk to the game over label? No. It will crash the project if the game over label gets changed. Its name gets changed, it gets moved, it gets deleted if you change your user interface stuff. So thank you, Joshua Morris, for that. That's interesting way to refactor your text, your variable names. All right, game over label. So we don't want the player to directly communicate with the game over label, because then what is it's called is it's now tightly coupled. Tightly coupled. We don't want our code to be tightly coupled. That's the problem. Watch one of my more advanced tutorials, especially I guess the updated one I plan to make in the future, to learn about decoupling your code even better. We don't want the game over label to be coupled to the player script. So what we're going to do is we're going to rely on good old Uncle Game State. Good old Uncle Game State. So under Game State, Game State is not going to communicate with game over label directly either. In fact, it would be really annoying to try to do that. So don't do that. Instead, we're going to create a new variable, and this one is going to be isGameOver. And we're going to set it to false by default. Okay, so this is going to be a Boolean. A Boolean that's a value that's either true or false. And isGameOver by default is false. When the player dies, we're going to say, Uncle Game State, I want to let you know something about me. And that is that I'm dead. isGameOver is now true. All right, very good. And I'm actually going to put it down here. It's okay to create new lines as long as they're still indented from the code block in this case. If areas in group enemy, self-like, if you do not put it here, this would work, except it'll game over instantaneously whenever it touches anything, right? It'll just boop, and now it's game over. So we don't want to do that. Keep it inside of that block. Very good. So now that we are able to let Uncle Game State know that isGameOver is true, anyone can know that we're currently in the game over state. This is now true. Anyone can know that. Who should know that? Well, who do you think? Game over label. It's like, really? Are you about to say that you're going to create a whole script on the game over label just to check to see if the game over state is true and to make itself visible? I'm going to do exactly that. That's exactly what I'm going to do. And you shouldn't be ashamed of it. It's fine. Okay, game over label. Game over label.gd. It's fine. And what I'm going to do is I'm going to do exactly what you expected me to do. Every single moment of the game, I'm going to ask game over state. We're going to ask the game state, yo, game state, is it game over yet? Is game over? And if it is, then what do we want to do? We want it to become visible. We want this to happen. Toggle visible. What does that mean? Just look at the property if you must. Scroll down. Look very carefully. Visibility. It's all canvas items have it. There's a property called, hover over it, visible. So we're going to say self.visible. Remember, you don't need self dot, but it just makes it more clear that we're talking about the visibility of the node is equal to true. Save it. Doesn't say game over right away, but when I run into this thing, the player dies, game over happens. That seems like amazing, magical even, but it's really quite simple. We just have a single shared Boolean that they are able to see through the game state Singleton that keeps track of whether it's, you know, game over is true or false. Once the player dies, just flip it to true. And then the label has no idea when or how, or well, it knows when, but it doesn't know how this game over became true, but however it did, it doesn't matter. It's now true, so let's go ahead and become visible. The game over screen is now visible. Now, if you want to be more verbose, here you can say equal equal true, and this will work the same way. Is game over equal equal true, which is to be exact, like is that variable equal to the exact value true? Yeah. If this looks like more clear to you, you can do that. It makes no difference. You can also just do this because remember the question, the if, is just checking to see if this is truthy. Well, the whole thing is a true or false value, so you don't have to say like, is it equal to true? Like you don't need to do that. So we can just leave it like that and that's fine. All righty, righty-roo. Someone asked the question that I was about to ask all the way, Constantine, I think. And I'm going to answer this question because I was going to answer the question anyway, which is like, is this going to cause like problems by checking constantly? How much processing power is this going to use to check? And the answer is like virtually none at all. Okay, your processor does like millions of, at least, of instructions per second. Okay. This is the most simple instruction. It's checking to see if a bit is 0 or 1. It's like the arithmetic logic unit is built to do this. Like you could do this 5 million times every tick and it would probably not notice. It is so basic. Like this is something that will do nothing to your game. Okay, this check is virtually, you know, free. So don't worry about that. But you're right. Process function is dangerous. Process function is dangerous because some things do use a lot of processing power. This is just not one of them. Okay, you're just like changing a variable value. Holy golly, somewhere in the house did something die? No, hopefully not, but all right. Cool, so the game over happens. Let's just do one last thing, you know what, and then we'll do the Q&A, and let's make it so you can restart the game, because that'll teach us one last thing, an important thing to understand about this, and we'll make it quite simple. The question that we want to ask, of course, the pseudocode we want to do, is when do we want to restart the game? Let's say when the player presses the enter key. Right? That's how you restart the game, when the player presses the enter key. Well, what, should we say the player? Should we have the player script ask that question? No, because if the player's dead, then the player can't restart the game. Should we do it in the main scene? Should the main scene check to see if that input is true, you know, like if the enter key has been pressed? You could, but then like, it's not really relevant to the level, right, that the player is pressing enter. That's more related to like a user interface. And we don't have a user interface. We just have these random labels, okay? So that would probably be a good place to put it. Or maybe something related to the player that doesn't die. Like maybe it's some kind of player controller that like handles input. So you have like some player controller node or something like that. You could do something like that so that the player can still die, but you can still use your, you know, keyboard. You could heck even freaking Uncle Game State could do it. You could put it in here if you wanted to. I don't recommend it because it's very hard to remember where you put it. Since it has to do with restarting, based on the nodes we currently have, let's do the game over label because the game over label is like the most related thing, even though it's not great, but you know what, whatever, quick and dirty. It's better than probably the other options. We already have a game over label script, so we're gonna ask the question, when has the enter key been pressed? I'm gonna come back to the actions here, but this time I'm not gonna make a new action. I wanna go to the input map. And what I wanna see is that this fire action is a custom action, but if I click show built-in actions and I click on this little toggle, you can see here are the variety of actions that come out of the box. And one of them is UI accept, which already has enter and space and all that junk. This seems like a UI accept kind of moment, right? It's a user interface, like I accept my fate kind of situation. So yeah, we'll just use this built-in action called UI accept. Very good. So just like before, we're going to check to see every tick if the enter key, if that action has happened. So if input dot is action just pressed, and there it is, UI accept. And if the UI accept has happened, we're going to print something. We're going to say enter has been pressed, so that it's not really enter, right? It's like UI accept has been pressed because space also works. But anyway, so I'm going to click play just to make sure it works. I'm going to look at my console. I'm going to hit enter. Enter has been pressed. Enter has been pressed. I hit the space bar, and that also works because UI accepts both. Okay, very good. So it worked. So what I want to do here is I want to reload the scene because that's what I want to do when we lose. This is a very important topic for beginners, and I think this is the last really important topic so that you can really be dangerous and really do the things that you want to do. The idea of the current scene. Okay, so how do we reload the scene, right? Can we say just like reload scene? No, because what the heck does that mean? Everything's a darn scene, right? Like the laser is a scene, an enemy is a scene. Like what scene are we reloading? What does that even mean? So in other engines, like that idea makes more sense because you have this concept of a level and you just like restart the level. Well, Godot doesn't have a concept of like a level. It's just everything's composed of scenes modularly, which is really cool, but it also makes this kind of thing, like changing levels and stuff like that, a little bit more confusing. But fortunately, Godot out of the box has a concept of what is called a current scene, a current scene. And by default, the main scene is the current scene. So when I hit play, actually, I'm going to undo this just so that it's, no. I want to keep this reload the scene thing. All right, very good. And when I hit play and I look at my remote here, you see how there's the root, there's the game state, and then there's this main scene business. I want to reload the main scene. Well, here's the thing. We can reload the main scene through a simple action. I just want you to understand the basis of how this action exists. And how I do that is I do get tree. When I say get tree, it's not getting the scene, it's getting the whole tree, including this concept of the root that's above the main scene. I'm getting the whole tree, okay? Get the whole darn tree. And when I say dot, you'll see that the tree, this idea of a tree is its own thing, okay? The tree is the scene tree. Notice how it's its own thing with its own properties. And one of those is the current scene, see? The node that is currently set to the current scene. And there are methods, as in like functions that belong to the tree, such as setting and reloading the current scene. Reload the current scene. You can set the current scene as well, okay, to whatever the tree is. That's what's kind of cool about this idea of the tree. All right, very cool. So that's what we're going to do. We're going to get tree, and we're going to reload. See, in fact, if I just do current scene, you can see reload the current scene property, and so on. So we're going to do reload the current scene. We don't want to know what it is. We want to just reload it. And again, by default, when you run the game, the main scene, that entry point that you specified at the very beginning when it says like set what the main scene is, that becomes the current scene by default. And you can change the current scene so that whatever it is next becomes the current scene, whatever other level you want. I recommend not doing that too much, but as a beginner, I think that's fine. All right. We're just going to get tree reload the current scene. So when I hit play and then I press enter, you'll see that enter, like the whole game reloads. And all the defaults are reloaded, okay? All the defaults are reloaded, generally speaking. But we don't want this to reload whenever I hit enter. I want to do it when. Well, first of all, let's get rid of this print statement. I want to, I don't want it to always, is action just pressed, UI accept? This will just reload the scene whenever we accidentally hit the enter key. We want to do it when two conditions have been met simultaneously, okay? So we can either, so the other action, by the way, the other condition is that we are in the game over state, right? So we can create what's called a compound if, like a nested if. So we can say if game state dot is game over, we can do that. Very cool. this is what we call a nested if. So once this becomes true, then we have to ask, is this also true? We can also do this. And so I'm going to show you this one last little fun thing, which is the and keyword. Okay, the little and keyword. This allows you to create this is what we call a logical operator. All right. It allows us to create complex logic. So we have a single if block, if structure that has two conditions, and they both must be true because we say and. Now it's now run off all the way over here to the side. We're still within 80 characters, which is within the style guidelines for Python's PEP 8, which I think Godot generally uses, but on my smaller screen, you have to go all the way over here to see it. So using one of those nested ifs is maybe better, especially if there's other things that you want to do with UI except. But we're on the game over label, so this is really the only thing that we're doing. And now when I hit enter, nothing happens, nothing happens, nothing happens, nothing happens, nothing happens. When we're in the game over state and we hit enter, now it loads. But uh-oh, why do you think that game over is still here? And why do you think score is still 10? When we lose and we hit enter, score is still 40. Is it really 40 or is it just the label that says 40? When I destroy something, it now says 50, so the score must be there still. And that's why I made it a point to tell you about this remote thing. Because when you reload the current scene, you're reloading the main node, okay? You're setting it back to its original defaults. But game state, Uncle Game State, is not related to the current scene, and so Uncle Game State's values are not changed. All right, score and game over are both properties of the game state that are not changed when you do that, and that's fine. You might be like, why would they do that? That's work, and I hate it. Well, really, is that what you want to do? That erases every single thing? How are you going to keep track of like high score? How are you going to keep track of how many, like what items a player has between levels? Like what? I mean, there are other ways to do it, but like you have to have some way to have persistent data, and this is one of those ways. So don't get too sad. So we can just do it here. You can probably a better way to do it, but for the sake of time, I'm not going to do it. You can have like a function called like reset values or something like that, and then here you can do. Well, why not? Let's just do it because I'm already showing you how to do it. Set score back to 0, set is game over back to false. So you're resetting the values. This way, in the game over label, you can do Uncle Game State. Why don't you go ahead and also reset your junk? Okay, reset the values. So do. Okay, I think we're done with our tutorial. Okay, I'm going to crash. Game over. Enter. Score is 0. Game over is invisible. Awesome. That's it. You might be like, what? This game isn't going to make any money on Steam. I thought you promised me money on Steam. I never promised you that. Even though the tutorial was relatively long up to this point, what I'm hoping is that I was able to show just basically the minimum amount of mechanics and features that showcase not just like, oh, look, this is the animation editor. Go watch a different tutorial about that. But like the actual nuts and bolts of the engine and how to approach it and think about it so that you can consider making any kind of game applying the same kind of principles. That's what I'm hoping you got in the most concise way possible. And I'm hoping that it was easy enough, in fact, maybe even the easiest of these types of tutorials for even somebody who is young or who has no experience programming. Hopefully this was something you were able to follow along with. So what I'm going to do is I'm going to take like a 2-minute break so that 3 or minute break, I don't know, so that you can catch up to this point if you want to kind of come back through, talk to each other in the live chat, think of what you might want to ask, and then I'll jump back in, I'll talk a little bit more, look through your questions, do a small live Q&A, and guess what I think I might do? And I might go, depending on how it works, I might have in a week from now another live Q&A so that if you weren't able to do the whole live stream right now or something like that, or you're watching it within this week and you'll have a week to complete the project, think of what you want to ask, and I'll host like another 1-hour live Q&A so that we can kind of go back in and answer some of these questions with this project open. So I can, hopefully, it'll be useful for people who are on all sorts of different time zones, except I guess you have to do the live Q&A. Again, that may be a bad time zone for you. All right, I'm gonna take a break for a second, and I'll be back in a minute. So I don't know how to do this like live chat thing. I don't want to like end the stream. So I guess I'll like type it here, like text. Cool. Thanks for watching. Be back in a few minutes for the live Q&A and advanced insights. All right. So I guess you see that. Make it real big. Oofy, 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 back. Probably not gonna. Here's the thing. Oh. All right. The live Q&A. So here's the thing. Phrase that weirdly. For people who are going to be browsing and checking Godot tutorials and they see, hey, look, it says that this is a Godot tutorial for absolute beginners. I don't want them to be scared away by like a 6-hour video because we stayed up all night, I guess whatever the heck time of day it is for you, doing this live Q&A. I think that's part of the function of having the one from like a week from now so that we can really talk more about it. So I don't want to go into too much time, especially since we've just been going for so long as it is. So maybe in the future I'll just do like a week later live Q&A. I don't know. Like, who knows? Like, this is all very new. This is my first live stream doing something. So let's go over a couple things just really quickly. One of the things that I had mentioned at some point was this idea that like touching the score directly can be dangerous. And I believe I did that here inside of the enemy script where we added 10 to the score. That's dangerous. I had mentioned that you could have accidentally said game_score equals 10, and then you messed up your whole score and you don't know where it happened because it doesn't tell you where it happened. Like, you could have said game_state.score. You could have accessed this in so many different places. And you could easily make that mistake. And so one safer way to do it is to create a function separately for it, and it's called you can just call it whatever you want. I call it increase score, and I say like increase amount or something like that, just however much we want to increase it. This is also the first time that I think that I've shown you how to write your own function that expects an argument. So when I say argument or parameter, you can use those interchangeably for the most part. Parameter is inside of the function definition. Argument is what the actual value you pass into it that gets loaded into this parameter, which is the variable that is used inside of this function. So here's where I could say score plus equal increase amount. So in this case, I can never accidentally like subtract my score or set the score equal to 0 or something, as long as I have the discipline to always use this function. Now this variable is still going to sit here. We can still accidentally use it. It didn't make it unusable, but it just makes you less likely to do it. Okay, that's why you want like the right people touching your code. Okay. So now you can say increase score, and I'm still using a magic number. I'm not going to, like, you can add that as a member variable if you want. So now if I hit play, just confirm it still works. If I shoot, yes, increase scores still works. So this is a little more obvious what it's doing, and it's also a little bit safer. Now there's other ways to handle this in what are called getter and setters. I'm not going to show you. I think that's more of an advanced topic, and you don't really need it. The syntax is a little weird, and maybe I'll show you at some other point. But getters and setters allow you to basically groom the data that comes in so that you don't accidentally set a value to something you don't mean it to be. So very good. That's one of the things that I want to talk about. I'm going to like kind of alternate. I'll answer a question that's over here. Any key says, do you come from Python, JavaScript, Elixir, something else, and don't use types often? Oh, I see. The question, I guess, I think kind of implies that like I'm like not saying like score int or something like that. Like I'm not being explicit about that. The reason why I did that is because I said that this is the easiest tutorial. Like I made that kind of lofty promise. This is for absolute beginners. Beginners who are coming from game engines like Construct and things like that, you really, don't really worry as much about the static typing and like exactly what the type is and stuff like that. I think for someone who, like, I have a computer science background, so it's very just natural to just like also include the type because it doesn't hurt. It's more, descriptive. It's more optimized. The code will run faster, and also you get type hinting. Like, since it doesn't know what is increase amount. It doesn't know if it's a number. It doesn't know if it's a node. So you can't just say like increase amount dot like add child. See, add child doesn't show up here because it doesn't know what it is. Right? This could be a node, it could be a number. And so having type hinting like this is helpful so that you can say something like, well, it is a node 2D. And because of that, like now I can do like I can do increase amount dot and then like add child, and there it goes. Because we are expecting it to be that. So it is good. There's no harm in like being explicit about your types, but you don't need to do it. For an absolute beginner who's a designer who's just getting into it, it's just it's like, what do we call it? Like psychological debt. It's just baggage that they just, even though it's not that hard to understand, it just adds more stuff to the code that makes the code a little bit more opaque. So, but the other answer to the question though is like, yeah, I do. I use JavaScript and all that stuff. Again, for those who didn't watch my like other thing where I was talking more about my background, yeah, I teach classes at the university, computer science background. I've taught Python, JavaScript. Like I taught all these different classes. So I'm very used to these things. And JavaScript and Python technically are not actually that similar in terms of types. You don't have to statically type, but Python is strongly typed and JavaScript is weakly typed. So they're actually a little different. We don't have to get into that. Cognitive overhead. I think that's a good word for it. Very cool. Now that we're on that topic, I do want to bring a gotcha that I just totally, like, how I went this far. Maybe someone pointed it out, but maybe no one did. Like, I just, you know, how was my poker face? We changed the type of these nodes to area 2D, but we didn't do anything to this extends node 2D. I didn't even mention it, right? Like what? Laser, player, they all still extend node 2D. Like what? See, I didn't mention it because I didn't want to overwhelm you with that. Because notice how it didn't make a difference. It didn't matter at all. This whole idea of this whole extends node 2D business is just, well, it creates like consequential things in two different places. One of those places, if you want to access properties that are specific to areas, right? So for example, over here on the right, area 2D has this idea of monitoring and monitorable and whatever the trash. If I said self dot like monitoring, it's not going to show up because it's node 2D. So really, at some point, you would want to eventually say this extends area 2D. And you can say self dot monitorable and monitoring. Now you can change those things. Okay? That's one place that's consequential. Guess what? For most people, they're not going to do anything with these stupid area things. Like linear damping, that's stuff that like the designer should do. Okay? You shouldn't do that in the code necessarily anyway. So you were able to still use the power of the area 2D. You're able to use the signals of the area 2D. Then what the heck? Why were we able to do that? Because the script extended something that the area 2D also was. If I was extending something that had nothing to do with anything, like, you know, label, then yeah, it would probably break stuff. But it's not. Like the play, if we do like add node and you see area is a node 2D. Like it down here, it is a node 2D. It is a node, it is a canvas item, it is a node 2D, it is a collision object 2D, and it is an area 2D. It's all of those things. So there's no actual problem with saying that it extends node 2D. We're just not accessing the specific features of area 2D in the code. That's all we're doing. So anyways, very cool. But that also, we do run into other problems doing this. And this is where these tutorials are limited. Because now you're gonna be like, I'm gonna go ahead and make my tower defense puzzle platformer or something like that. And you're gonna be like, oh my gosh, what? This tutorial was woefully inadequate for my puzzle platformer tower defense. Yeah, okay, this is dipping your toes. And there's little things that you're gonna run into that I kind of didn't, you know, I kind of like found a way around these kinds of issues. So for example, what if you had not changed the type of the laser to, or the enemy, or I don't know whichever one we did first. What if we made area a child of enemy instead of, like, what if we kept enemy as node 2D and we changed the area 2D to be a child, right? Well, so I'm just going to go ahead and make area 2D a child just so that it's here, just so we can see it. Yeah. Well, what are we going to do? Here's the problem. If we had done that, it would be fine. It would still work. We can do area entered and we can just connect it to enemy, the node 2D. Remember, just like the timer script, we were able to connect timer to its parent. Like it's fine. Like it doesn't have to be on the actual node. So I can connect my area 2D to the node 2D parent, and that would have seemed fine, and that would have been fine for a while. But here's the problem. As soon as you got into like more complex stuff, like in the script, where we check in the laser, is the other area in the group enemy? Well, you see the problem with that is, well, wait a minute. If the area is a child of enemy, then the group would have to be on this child, right? It would be like, so that's more silly, right? Because now it's like, wait a minute, if we make the group like enemy area, is that going to be the name of the group? That's already, it's awful, because it's like, well, other enemies might have multiple areas, right? Depending on how it's like designed, or not multiple areas. It might, Other enemies might not have areas like this, right? You see what I'm saying? Like if it's a boss enemy, maybe it doesn't have like an area like this. You know what I mean? And we want to be able to still check if the enemy is like part of this particular group in a place that has nothing to do with like, is the projectile hitting an area, right? Like we have a separate weird, just like one purpose, like enemy area thing. Like it's just not very convenient, I think, personally. And then so you're right. And so it doesn't seem like it's necessarily that off, but it can run into problems. Okay? Especially, let's say that we had done the way that I said you shouldn't do, which is like if the enemy collides with something, we do self.q free, and then we also destroy the other object because it destroys the laser and it destroys the player. So why do we need to go through all the effort of having a player script and a projectile script that have their own on area entered? It seems excessive, right? When we could just say like area.qfree, right? And if we do that, if we did area.qfree like this, let's say we did this, right? And I'm going to go ahead and go back to the player, and I guess I'm just going to eliminate this whole QFree thing, and I'm going to come back to the laser, and I'm going to get rid of this whole thing. So, and I have to do pass, because remember, it's going to hate me forever until I do that. If I do this and I shoot, let's see if it works still. I didn't like think about it too heavily. It still works. I got rid of that other stuff, right? And it still works. It still says game over. So that is a way that you could think as a beginner to be like, oh, see, like I didn't have to do all this extra work since I was able to just do that, right? Well, here's the problem. See, if you had made Area 2D a child of the player and a child of the laser, you see how area.qfree would have deleted the child? It wouldn't have deleted the enemy, like the player would have just deleted the player's area. Right? It's like, okay, well, we couldn't do that. So it's like, oh, area dot like get parent. See, this is how you get yourself in trouble. This is how beginners and even intermediate people get themselves in trouble. They start doing this kind of stuff. Like area that, well, you know, like we want to destroy its parent. We don't want to destroy the child. You know what I mean? Like we don't want to destroy the child. We want to destroy its parent. So we're going to do area dot get parent. Now, not only is it coupled, but it's like obsessed with a particular structure. If like the designer changes it so that like the area is no longer exactly as a child, or maybe there's other parts in the way or some other thing like that. And it only works for areas that like are direct children of the thing we want to destroy, right? Like what if the area itself is the main node for it, right? The root node for that scene. You're going to destroy the main scene accidentally by doing area.getParent. Like this is what I'm talking about. You get yourself in trouble on things that like look great and seem to like be easier than, you know, other things, but you don't do it, right? You see what I'm saying? See what I'm saying? I'm just trying to give you some insights into the problems that you run into when you go down a path. It's okay to refactor it. And sometimes you can't think that far ahead. So just keep going. Keep going until you crash and burn, and then refactor. Refactor early though. As soon as you realize there's a problem and you can think of a better way to do it then. Do it then. Don't wait and be like, eh, well, it's almost done. Let's just keep going down the path of horrible tragedy. All right. So that's another kind of insight that I wanted to talk about a little bit. I had mentioned the idea of the collision masks and stuff. Maybe that's another way to do it, and that also would like have prevented you from having to check to see like under laser, just so we can be like totally rounded out. Notice how, I guess I'll bring this back. You can keep pass here, it doesn't really matter. But and also player. Yeah, let's bring this back. Drats. All right. So like we have to check to see if it's in this enemy group. There's a way that requires like no additional code. You don't have to do this is area in this thing. You don't have to check is the area in the enemy thing. You don't have to worry about it at all. And you can do that by messing around with what are called collision masks and collision layers. And some engines like really like to do this. I don't think it's very intuitive to a beginner, to be honest. It's this idea that the layer is the like the type of collision that it belongs to, right? It's basically like, it's like the color of the shirt you're wearing. Let's say you're wearing a red shirt, okay? The mask is the shirts that you can see, right? It's like, so if layer 1 is red shirt and mask is red shirt, then you can think of it like goggles, right? Like, you know what I'm talking about? Like freaking ski goggles that can only see like one color. It's like that, right? It's like, I'm wearing a red shirt, and then mask is like my ski goggles that can only see red shirts. Okay, see what I'm saying? And so some people that makes sense. To me, I think it's actually kind of more confusing, and it's also kind of obtuse because like, it's not obvious that you've messed with the layers. Like, see, if I do this and stuff, like, it doesn't show up anywhere over here. It certainly doesn't show up in the code. So like, when things are kind of not working exactly as you expect, you have to think to like expand this little collision like thing in every single area to like see where they are. And you might think like, oh look, well you can edit the layer name so you can call layer 1 like red shirts or something like that. Like, see, isn't that good? No, it's not good. It's still called 1. It just allows you to say like red shirt here. It's like, no. It's still not very obvious. But the way that you would use it though, and I don't want to go into too much detail here, is basically, okay, projectiles are able to see what? They're able to see enemies because they destroy when they touch an enemy, right? So the enemy can be on like layer 2. That's like, you know, and no, what are we on right now? I don't know. Yeah, enemy's on layer 2, and it can see both. Well, maybe it doesn't see enemies. It just sees things that are on layer 1, which are the projectiles in the player, perhaps. And then on the projectile, it can only see things that are on layer 2, because it'll only get destroyed if it touches an enemy, not when it touches a player, right? It doesn't see red shirts. It only sees blue shirts, right? So for like the projectile, what you can do is like the laser. I mean, you can say like it's on layer 1, but it can see only layer 2, right? It can only see enemies. You know, you can do that, and that's fine. But it's just, I don't like it personally that much. It's okay if it's like environmental stuff that you're just trying to like keep away from like the player accidentally like running into it. I think that's mostly fine because that's just like environmental. That like the designer can kind of mess around with this stuff. But if it's like has to do with meaningful relation to your like code, keep it in the code. By you asking this question under laser, like, is this an enemy? It's descriptive, it's obvious, you can see it, and like you understand what's going on. It's not like some other weird secret stuff going on in the inspector that you don't think to check. Okay? Keep the programmer as much in the programmer part as possible if it has to do with mechanics. At least that's my experience. All right, very good. I want to like check to see if any of you have additional questions. Metroidvania, I agree. Mask will see eye is what it sees. It seems like you folks have like kind of thought of it a little bit already, or maybe you've heard of it from other tutorials. I confess I have not really watched a lot of the tutorials on YouTube. So some of you might be like, yeah, man, you should check out these other folks. Like they know what they're doing, and maybe they do. But there was a time where I did check tutorials, and I have checked like recently to some extent, and it was enough that I feel like my style of teaching stuff was different enough that I felt that I could reach people who like this style better in a way that there isn't really anything else. But it would be kind of useful to see what other people say. At the same time, sometimes I don't want to see what other people say because I kind of want to like come up with my own like weird way of explaining it. I can skip back for this, but Uncle Game State was the only singleton that we used, correct? Yes. Uncle Game State. Why did I call it that? That was just on the fly. It was like unscripted. So I mean, this whole thing is pretty unscripted. So, anyways, yes, that was the only singleton. Ta-da! Game state. Now, of course, you can have other game states in the future, but this is a relatively simple thing. And from here, you can actually expand it pretty easily. You can do like animation editor stuff, and you can do like, you know, animated sprites and stuff, and music and junk without changing much. You're not going to break much. If you keep like the patterns that you've created here, the design patterns that you've created, and you don't mess it up, it's really like enough that you can make you can scale up the game without too much trouble. Why not a signal, says Heirachy. I don't remember what you're referring to, but yes, that's a good question. And the reason is because in my experience, and I've taught beginners for a very, very, very long time, and signals are extremely powerful. I'm just reserving that for a different lesson, because with this Uncle Game State stuff, that I've taught you where you don't try to communicate with other nodes directly. You try to keep things decoupled. This principally is very similar. The idea of using a singleton with like variables that they are able to refer to separately. Okay, you're just one step away from this idea of using signals, where instead of like checking is game over directly, or increasing the score directly using like a function like this and stuff like that, you would instead create a special signal, okay, your own custom signal that you emit. Like, for example, when the player dies, instead of like the player saying, hey, game over, you're true now, which is somewhat coupled, but it's only coupled to a singleton. So it's not like it's going to break the game if, the structure of your nodes changes. But instead, you just say, I'm dead now. You don't, that's the only meaning that the player needs to know, because when the player dies, the player doesn't necessarily need to know what has happened and that now that it's dead, right? You can just say, hey, I'm dead. And then when you emit that signal, anyone who has subscribed to the concept of player's dead now, which is managed through a singleton, all that stuff gets updated at the same time. Not just game over. It might be like saving the high score. It might be like, freaking playing a sound effect that does this or that. I don't know. There's so many other things you can do, obviously. And so you don't want to handle all of that right here in the player, right? Where it's like setting game over to true. You don't want to like say like game state dot also these other things that have to do with game over. Sure, you could create a function that would bring you one step closer, a function called like, handle game over, and then Uncle Game State can have a function called like handle game over. But there's a bunch of things that like are specific to other nodes that the game state doesn't know about, right? And so it's, yeah, this doesn't scale too well, but the mentality is where I want you to be so that you can learn about signals. The problem with the thing is the signals with beginners, in my experience, signals are just like one step too abstract. I'm trying to teach this basically to a 12-year-old, right? Imagine I'm trying to teach it to like a 10-year-old or something like that. How is a 10-year-old going to be able to digest this? I think for the most part, the stuff that I taught is a little bit difficult, but if a 10-year-old watched this enough times, I feel like a 10-year-old could get it and could do really cool things inside of game jams. I think signals are at a point where they're not valuable enough to like 10-year-old who just wants to make some cool games that his, their friend wants to get into. You know what I mean? Like that's my mentality. So very good. That's why I plan to make these other tutorials. I do have that other like 7.5 hour tutorial. What else? You returned, awesome. Will you do a tutorial on Godot shaders in the future? Maybe. Are there not a lot of tutorials already on Godot shaders? You should also show plane free to not mistake it for the same. What? You should also show plane free to not mistake it for the same. Show that it exists, but not to use it. This is one of the problems with this. I don't remember the context of what you meant by that. Maybe I'm just being kind of like dense that I can't think of it. Paxine adds that as a child, right? Yes, hopefully other folks were helping with that. Hopefully you figured that out. You can rewind it, if you ran into problems. I like these because the tutorials where you're just not told to copy code. Instead, you get an in-depth explanation. Well, I appreciate it because we definitely didn't go into we didn't make a very pretty game. We didn't make like explosion effects because like, come on, you can make an explosion. It's like, how to do timers. So you can make the explosion thing disappear. You know how to spawn something at the location of something, right? Like you can do it. Like you don't need me for that. Like, come on. I like to spend more time in the places where you're gonna get in trouble than like it being beautiful, Not sent but stored. Yeah. I probably used slightly wrong words here and there just because like it's a tongue twister, folks. Sometimes. Dang, so glad you're making videos again. You give so much wonderful information for Godot and programming. We'll be watching later. Stopped by to thumbs up and say thanks for all the bits. Thank you. Now I'm reading these comments because I think I have the live chat to like delete itself when it's done. And the reason I do that is because like I suppose it's possible for someone to come here and just like go spam crazy and just like say a bunch of like horrible things. Potentially, and then it's just like ingrained in the video forever. Maybe, I don't know. I don't want that to happen. So, I want to make it so that I can easily, you know, like just still repeat the comments so that we can hear them, just prevent, you know, the wrong kind of comments from being memorialized or immortalized. I don't know. This is not what I expected to see in the morning. Welcome back. Oh, I don't know where you live, but it's not morning here. I made this mistake unintentionally with the tile map, and it caused my pathfinding to break. Had a time trying to figure out this one out. Well, hopefully you figured that out. Yeah, the tile map stuff I heard is a little tricky. Sorry for me, it's like 0 o'clock. Yeah, sorry. I tried to like I started it when like Western Europe was like still mostly awake. Maybe not. I don't remember. The United States was fine. This was just the time that like it was quietest in the house. I had to do it at this time. It's late at night, folks, where I'm at. Thank you for your humble answer. I'll be doing my best to put this knowledge to good use. Good luck on your journey. Thank you for your information. You can also use Alt key to move that node without selecting other things, but you need to hit the pivot point at the node. Thank you. There's a lot of really cool, like really convenient stuff here that I did not show you at all. Because again, that's stuff that I feel like a beginner can go to any tutorial and learn those things. And you don't need those things in order to like, you know, those are things you'll just learn eventually. Be like, oh, that's a neat little feature. But it's not going to cause you, this is like the little like editor stuff, you know, scaling stuff and holding Alt to do stuff and like going through all these things. Like not knowing about that is not going to cause you to like hate your life enough to not use Godot, you know. But the other things where it's like, I can't get it to work at all. That's the stuff that I wanted to focus on. Can you change the position before adding? Yeah, I already answered that earlier. Gosh, there's so many comments. Control Shift R, yeah, that was the thing. Where we wanted to be able to change the area. See if I wanted to change this to other area, for example. Like, notice how this, like, what if this gets referenced a lot of different times? We could accidentally break our code. In like Visual Studio Code, using like a supported language, you could just like hit F2 or something like that, or you can right click and do refactor, and you can change. But I think you said use Control Shift R, find area, and replace it with other area. So the problem with this is I think it's going to, like, if there's area up here too, it'll like also change that. And that's where I want to be careful, right? See, I can do replace. Oh my gosh, what have I done? Oh my gosh, it's like noticing it here and here. Don't change it there. Oh my God, did I accidentally change everything? Yeah, see, I do not want to change this to other area 2D or something like that. This is where I'm like already like nervous. Like I just want to, no. Replace all, no, undo. No, please don't. No. How do I tell it to stop? Get out of here, escape. Control Shift R. Abort. You're like, this is what I'm talking about. Like, it makes me so nervous. In other editors, you can just like hit F2 here, and it knows that it will only change the name of the variable. It's able to parse through here and recognize like what counts as area, what counts as like the member variable, and all this other stuff. So I personally would probably avoid that. Just name it right the first time if you can. All right, what do we got? And we'll probably have to close it out in just a few minutes. I like to spend time at places where you're going to get in trouble. Yes, that's where I want to be. I want to be there in video form, or maybe even live stream form in some way, when you are like crying because your code just doesn't work, or you've run into like like the thing that I'm talking about with like the child area business, where it's like, what have I done? How can I get out of this bind? And be there to pull you up, rather than like, oh, look at this feature. If you press like T on your keyboard, then like now you are in some other kind of like viewport mode. That's not a thing, but you know what I mean. 1043 in Connecticut? Yeah. Hey, the fact that I knew that CT meant Connecticut, I think, is a revealing thing. You did have what sounded like a cat attacking a pile of dishes, so mostly quiet at this hour. Yes, I'm actually amazed that it's been so quiet. My goodness. I don't know what I'm going to do for the like probably it's gonna be like an 8-hour advanced tutorial with a 3D. Holy moly, I'm probably gonna have to do it like midnight to 8 in the morning again, like I did last time. LMAO, got the visual on that one. Yeah, LOL, I mean, I did add a warning that it's still done. Okay, folks, I think there might be other advanced, but I want to, leave a couple of these advanced insights, if there are any more, for that Q&A, which maybe no one will attend. But you know what? I'll put the call out probably early so that you can kind of adjust your schedule if you like. Maybe make it slightly earlier in the day for most people in the world. And we'll see how that goes. If like nobody attends, I don't know, maybe we'll pivot to something else. I did get as many of these little insights that I kind of wanted to get. And you folks are awesome. You really make this worthwhile to me, that like some of you stayed along for the ride. I think someone mentioned in a comment on like the other video, it's like, it's going to be a mistake to live stream these tutorials because you're just going to get distracted by all the messages in the chat. I hope you didn't feel like I was too distracted. If you are watching this pre-recorded, hopefully it was relatively seamless for you. Me doing it this way, I guess it just makes it more natural. Makes it less likely for me to be like, oh, whoops, I made a silly error. I'm going to stop the recording and like start over or something like that. I won't be tempted to do that because I can't. That kind of thing. And so hopefully this format does work to some extent. We'll see. For me, I feel like I'm less alone. It's a little bit less lonely that I see a comment happen every now and then. Maybe I'm just fragile, but cool. Thank you so much. Thank you so much. Expect more of these videos in the future. Hopefully I won't disappear for so long again. Watch that other video I released, was it yesterday, if you want to learn more about kind of what I'm thinking moving forward. And I wish you all the best. And I hope that you learned something today. So good luck with your project, and I'm wishing you peace.